Hello guys, welcome on Tesla Adventures. In this video, we are going to discuss the solutions of NSEP 2024 and the answer key will be released on 21st of December, but I'm releasing this solution video and I'm pretty much sure that answer key will not deviate from the solutions of mine. But in any case, if one or two questions may deviate, if in case, then we will correct those questions and we will reload the video. But I am sure that there would be no deviation in the answer key. So let us start from the first question itself. You can see that this is a Bohr's model question. And let us also tag the question. It is from modern physics. So in this question you can see that the force acting on the electron by the nucleus is given by this F, and Bohr's radius is this one, A0. So we have to find out the radius of nth orbit. So we know that what we have to do, that we have to compare this F with mv square by r. So let us compare this F with mv square by r. So let us write it down as e square upon 4 pi epsilon naught. R square is common and this is 1 plus del by r. And let us compare it with mv square by r. Now cancelling this r with r, you can see that v will be equal to e under root of 1 upon 4 pi epsilon naught m into r, and this is 1 plus del by r. And we know that mvr is also equal to nh upon 2 pi. So we will substitute the value of v in this equation. So this would be equal to mvr. Now we are substituting r, so it would be, we are substituting the value of v, so it would be e under root of mr by 4 pi epsilon naught, and this is 1 plus del by r, and that is equal to nh upon 2 pi. So if we square these both sides, so it would be e square into mr divided by 4 pi epsilon naught and multiply by 1 plus del by r, and that is equal to n square h square by 4 pi square. So cancelling this 4 with 4, pi with pi, so we have to find out the value of radius. So r, we are multiplying it, so it would be e square m by epsilon naught. This is 1, in fact this is r plus del, and that is equal to n square h square by pi square. So the value of r will be equal to n square h square epsilon naught divided by, and this is only pi, okay, yeah, so it is divided by e square m, and this is pi minus del. Now we know that the value of Bohr's radius is for n barabar 1, n is equal to 1, so it is epsilon naught h square upon pi m e square. So this is epsilon naught h square upon pi m e square, so r will be equal to n square a naught minus del. So the correct answer will be n square a naught minus del, which is option A. Now let us move on the next question. In this question, you can see that there are infinite number of rings which are having different radius, and the radius are having a special sequence, that the first ring is having a radius of r, then the next ring has the radius 2r, then the next ring has the radius 4r, and so on. and they all are placed concentrically on a plane, and all the rings carry same current, but current is in opposite sense in the consecutive rings, which means that in this smaller ring it is in anti-clockwise sense, and in the next ring it is in clockwise sense, then in the next ring it is in anti-clockwise sense, and then clockwise, and so on. So we have to find out the magnetic field produced at the center of the rings. So we know that the magnetic field formula for rings is mu naught I by 2r. So, for if we write down the net magnetic field for all the rings, then it would be mu naught I by 2, and for the smallest ring it is 1 by r, then for the next ring minus 1 by 2r, then for the next ring plus 1 by 4r, then minus 1 by 8r, then plus 1 by 16r, then minus 1 by 32r, and so on till infinity. So we know that this is our GP, and if we take common as r, then this is this is two separate GP. So this is 1 plus 1 by 4 plus 1 by 16 and so on, and here it would be 1 by 2 minus, in fact, plus 1 by 8 plus 1 by 32 and so on. So B will be equal to mu naught I by 2r, and we know that the sum of GP is A upon 1 minus r, so it is A, which is 1 upon 1 minus 1 by 4, which is the common ratio. Common ratio is 1 by 4, so 1 minus 1 by 4 is 3 by 4. So it is 4 will be on the numerator, and in the denominator it would be 3 minus. So in this case the first term is 1 by 2. So 1 by 2 upon 1 minus, again the common ratio is 1 by 4. So this is 1 minus 1 by 4, which is this would be equal to 2 by 3. So you can see that B will be equal to mu naught I by 2r into 4 by 3 minus this is 2 by 3. So it would be 2 by 3, and cancelling 2 with 2, it would be mu naught I upon 3r. So the correct answer will be C. Now let us move on the next question. In this question you can see that 1 mole of an ideal monatomic gas, which is initially at a temperature of T, is heated in such a way such that its molar heat capacity during the process of heating is C is equal to 2R. Now this gas is heated at constant pressure, and its volume is tripled during this process. So we have to find out the final temperature attained by this gas. So we can say, first of all, that we know that C, which is the molar specific heat capacity, is R upon gamma minus 1 and plus R upon 1 minus R. This is for polytropic process. We know this formula. Now gamma for this monoatomic gas, gamma is 1 plus 2 by F, and F for monatomic gas is 3, so gamma is 1 plus 2 by 3, and therefore it would be 5 by 3. So C will be equal to R upon 5 by 3 minus 1 plus R upon 1 minus R. Now C is equal to 2R, so this is 2R, and this is 3 by 2R plus R upon 1 minus R is equal to 2R. So R upon 1 minus R is equal to, this is R by 2, and 1 minus R is equal to 2, so R is equal to minus 1. So this is R, and we know that for polytropic process T V ki power gamma minus 1 or n minus 1 is equal to constant. Okay, so this is for polytropic process, and you can also derive this expression by PV to the power n is equal to constant. you can replace the value of P as nRT upon V. So this will be the formula. So now if you substitute the value of R in this N, then it would be TV to the power minus 2 is equal to constant. So we can say that T is proportional to V square, which means that if volume of the gas is tripled, then obviously the temperature will become 9 times, which is 3 to the power 2. So the correct answer is B. Now we move on the next question. In this question, you can see that there is a spring that is compressed by the force, constant force F. So let us suppose that this is a spring which is compressed from its natural length by a distance of x naught by a force F. So x naught will be F by K. Now suddenly this force, now I have assumed this epsilon as x naught, so it doesn't matter. So now suddenly this force is reversed, and suddenly the magnitude is doubled. So we have to find out the maximum extension to which the spring will be extended beyond the natural length. So this is the natural length position, and if let us suppose that we have reversed the direction of the force and we have doubled the force, then what we'll do, that the work done by this force, let us suppose that spring has been extended by a distance of x from the mean from the equilibrium, in fact from the natural length. So the total work done by the force 2F will be 2F into x naught plus x, because x naught plus x is the total displacement of the spring, and this work done by the 2F force is equal to change in potential energy of the spring. So this change in potential energy is half K. Now final potential energy is half kx square, and the initial potential energy was half F square by K. So this is 2F and x naught is F by K. So this is 2F square by K plus 2Fx is equal to half Kx square minus F square by 2K. Okay, so this is half Kx square minus 2Fx and minus 5 by 2 F square by K. So we will take the 2 LCM, 2s common, so it would be kx square minus 4fx minus 5f square by k is equal to 0. So this is a quadratic equation, and the value of x will be plus 4f plus under root b square plus and minus, obviously I know, so let us put that minus also. So b square is 16f square, and 4ac minus 4ac is plus 20f square divided by 2k. So x will be equal to 4f plus minus, this is under root 36, so it would be 6f divided by 2k. And if we will use this positive sign, obviously, because x cannot be negative, so this will be 10f by 2k, and hence it is 5f by k, and f by k is x naught, so it is 5x naught, and obviously x naught is this epsilon, so the correct answer is D. Now let us move on the next question. In this question, you can see that there are two positively charged spheres, and the masses are different. They are connected with the ropes of same length L, and are hinged at the same point, this point. So this system is in equilibrium, and in equilibrium they are subtending, their ropes are subtending an angle of theta 1 and theta 2 with the vertical. So we have to choose the correct relation between theta 1 and theta 2 for the given system, and assuming that obviously system is in equilibrium. So this is a very simple question, and let us do one thing. We know that the force, electrostatic force applied by M1 on M2 is this one, and the electrostatic reaction force applied by M2 and M1 is this one, and the tensions are acting like that. So you can see that the internal forces are F and tension, and the external forces are M1G and M2G on both of them. So we know that if system is in equilibrium, then net torque would be 0, and we already know that the torque of internal forces is 0 always. So we can balance the torque of mg, and therefore we can write down the torque of m1g as m1g sine, in fact m1g into L sine theta 1 will be equal to m2g into L sine theta 2. So cancelling g and L, so m1 by m2 will be equal to sine theta 2 by sine theta 1. So this will be the correct answer, and therefore sine theta 1 by sine theta 2 will be equal to m2 by m1. So the correct answer would be option B. Now let's move on the next question. In this question, you can see that there is an air-filled parallel plate capacitor whose plate area is A and the separation between the plates is D. So let us draw the scenario. So this is the situation, and it is connected to a battery which is having zero internal resistance, and the EMF of the battery is V. And one of the plate of the capacitor vibrates with an amplitude of A. It is vibrating like that. This is A and this is A, and with the angular frequency omega. So we have to find out the instantaneous current, which in fact it is given that the instantaneous current reaches to a maximum value of I naught. So we have to find out the amplitude of vibration A in terms of instantaneous current. So we know that C is equal to epsilon naught A by D, and let us suppose that this is X, and obviously Q is equal to CV. So Q is equal to epsilon naught AV by X, and dQ by dt is the current flowing, so it would be epsilon naught AV divided by X square, and with a negative sign, obviously we are ignoring that negative sign, and into dx by dt. So this is the differentiation of this term. Now dx by dt is the velocity, and I will be equal to epsilon naught AV by d square. We are assuming that A is very small, so the average value of x is d. So this is obviously velocity v, and the current will be maximum when velocity is maximum, and in SHM V max is A omega. So I naught will be equal to epsilon naught A V divided by d square into A omega. So the value of A is I naught d square upon epsilon naught A V omega. So the correct answer will be option A. Now we move on the next question. In this question, you can see that there is a small ball of mass m that is attached to one of the end of a massless unstretchable string of length L, and it is held at point P. The other end of this string is fixed to the support O such that this OP string is horizontal. So we have to find out that what minimum velocity u we should give this ball at this position so that ball can complete vertical circle without any slack in the string. Obviously, we know that for completing vertical circle, the required velocity at the lowest point with the string is under root 5 gl. So let us apply the energy conservation between point P and this point A. Let us name it as A. So we know that obviously half mu square is the kinetic energy given at this position, plus work done by mg is mgl is equal to energy at A, which is half mv square is 5gl. So half mu square is 3 by 2 mgl, and cancelling m with m2 with 2, u is equal to under root 3 gl. So the minimum velocity that we should give this ball at this position is under root 3 gl. So the correct answer is B. Now let us move on the next question. In this question, you can see that there is a illuminated point object which is kept in front of a lens of focal length f is equal to 40. This is a equiconvex glass lens, and object is placed at a distance of 120 centimeter. Now if let us suppose that the distance of plane mirror from the lens is x behind the lens, and the first image of this lens is 1 by 40 is equal to 1 by v minus 1 by 20, which is minus minus plus. So 1 by v is 1 by 40 minus 1 by 120. So LCM is 120 and this is 3 minus 1. So it will be 2 by 120, and therefore V will be equal to 60. So as you can see clearly that in all four options, this all the values are less than 60. So obviously we can assume that x is less than 60, and therefore this ray diagram would be like that. So this distance will be 60 minus x, and obviously the image of the mirror will be in the front, which is at a distance of 60 minus x, and this image of the mirror will be the object for lens again, because rays will go from the lens in this direction, then they will be reflected by the mirror and they will travel again from the lens in this direction. So now for lens, the object is this one, and this distance will be x minus 60 minus x, which is 2x minus 60. And now we know that the final image should be formed at mirror itself. So for second refraction through lens, u is equal to minus of 2x minus 60, and v is equal to minus of x, because we have to make the final image at mirror. Okay, so obviously final image will be virtual because rays are going in this direction and image is at this position, so it would be virtual. And 1 by 40 will be equal to 1 by v minus 1 by u, so it would be plus 1 by 2x minus 60. Now instead of obviously solving this equation for x, you can just put the values of these options, and we also know that the final image would not be the real image, so the possible answers can be 40 or 50. Let us first of all put this 40. So 1 by 40 is equal to minus 1 by 40 plus this is 1 by 20. So you can see 1 by 40 will be equal to 1 by 40, which means that this is the correct answer. Now we move on to the next question. In this question, you can see that a ball is kicked from the top of a hemisphere in such a way such that it does not touches the hemisphere again at any point in its flight. So we have to find out the value of D where it will land. So first of all, we know that at this position if we are giving sufficiently enough velocity so that its normal reaction becomes zero, then it will leave the contact with the hemisphere at this position and never fall back on the hemisphere. So for normal reaction at this position to be zero, we can draw the FBD and we can see that mv square by r is balanced by mg and v is under root rg. So this velocity is given at this position. Now time of flight is under root 2r by g, and the range, if I say the range, let us name the range as OD. So OD is the range and range will be equal to V into T. So OD will be equal to, this is R under root of 2, root 2R. And obviously the distance D will be equal to root 2 minus 1R. So B is the correct answer. And obviously this is not the critical velocity, because in this case the ball will go like that. From inside the hemisphere it is not possible. So the correct answer is B. Now let's move on the next question. In this question you can see that the two blocks are hanged from steel and brass wires, and the ratio of length, radii and Young's modulus of a steel to brass wire is alpha, beta and gamma respectively. So we have to find out the ratio of the increment in length of steel and brass wires. So we know that delta L by L is the strain, and strain is stress, which is force, or we can say that tension per unit area divided by Young's modulus. So stress by strain barabar gamma is equal to gamma. So delta L steel upon delta L brass will be equal to, first of all, tension ratio. So we know that tension in steel is 50 and tension in brass is 30. So this is 5G upon 3G. Next, we know that the length ratio is L steel upon L brass, because delta L is directly proportional to L, and the ratio of gamma is gamma brass upon gamma steel, and the ratio of area is pi r square. So obviously it is inversely proportional, so r steel whole square upon r brass whole square. So this delta L steel upon delta L brass will be equal to 5 by 3. L steel upon L brass is alpha, and gamma steel upon gamma brass is gamma. So this is 1 upon gamma obviously, and R steel upon R brass is beta. So this is 1 upon beta square. So the correct answer is 5 by 3 alpha by gamma beta square. So B is the correct answer. Now let's move on the next question. In this question, you can see that there is a uniform beam of intensity I is 60 milliwatt, which is 10 raised to power minus 3 watt per meter square. And it is incident on an sphere which is perfectly absorbing, and the radius of the sphere is 2 micrometer, which is 10 raised to power minus 6 meters. The density of the sphere is 5 into 10 raised to power 3, and this sphere is placed in a room where no gravitational force is acting on it, and we have to find out the magnitude of acceleration of the sphere due to this radiation force. So we know that the radiation force on a sphere is I by C into pi r square. This we have already derived in the modern physics playlist. You can find the video. And the acceleration is F by m. So this is I pi r square by C, and mass is density into volume. Density is rho, and volume is 4 by 3 pi r cube. So cancelling this pi with pi, r square with r square. This is 3I by 4C rho and R. So if you substitute the value of this 3. This I is 60 into 10 raised to power minus 3, and C is 3 into 10 raised to power 8. Rho is 5 into 10 raised to power 3, and R is 2 into 10 raised to power minus 6. So cancelling this 3 with 3, this with this is 15, this with this is 3, and this is 3 by 2 into 10 raised to power, this would be minus 8. So this is not matching with any of the answers given. I think if this was megawatt, and mega means 10 raised to power 6, so there would be a difference of 10 raised to power 9 here. So the answer would be, I think, then also answer is not matching. So this is a question in which no answer is matching. So let us see that what NSEP will give in answer key. So let us move on the next question. In this question, you can see that there is a fuse that is having a cutoff value of 4 ampere, and the fuse has zero resistance till it is not blown, and as soon as fuse is blown, when the current will reach 4 ampere, it will blow out, and it means that it will offer infinite resistance. So we have to find out the time in which the fuse will blow after closing this switch S. So obviously, let us suppose that at T time fuse will blow. So before fuse blows, the circuit would be like that. So you can see that this 15 ohm resistance will be short circuited. Okay, and the current will flow like that, I. So we know that the complete voltage will occur on inductance, and therefore L di by dt will be equal to 10. Now L is 5, so 5 di by dt will be equal to 10, and di by dt will be equal to 2. So I will be equal to 2t. So fuse will blow at current of 4 ampere. So 4 is equal to 2t. So t will be equal to 2 seconds. So at 2 seconds, this fuse will blow, and then it will offer infinite resistance to the circuit. So answer is A. Now let us move on the next question. In this question, you can see that there is a two-dimensional magnetic field which is in X as well as Z direction. Now there is a wire PQR which is bent in form of this V, and this angle is 60 degree. Okay, some current I is flowing in the wire, and the length of this wire is L and this wire is L. So we have to find out the net force acting on this wire due to the magnetic field. So we know simply that we can draw an equivalent wire of this wire, which is this one. I'll draw with the different color. This will be the equivalent wire. So this is equivalent wire, and it would be having the same length L because it is a equilateral triangle. So this is a equivalent wire, and it is carrying a current I which is equal to 5 by 2 ampere, 2.5 ampere. And the length of the wire is 2 meter, and the magnetic field has two components. So what we can do easily, that we can separately find out the magnetic force by both of the fields. So you can see that one of the field is in X direction, this is Bx, and it is 3 Tesla, and one of the field is in Z direction coming out of the plane, which is Bz, which is 4 Tesla. So you know that this wire is parallel to this component of magnetic field, and therefore the force acting on the wire due to Bx will be 0, and the force acting on the wire due to By will be the net force. Due to Bz, in fact, will be the net force, and Bz will be acting on the wire in the downward direction. You can see that it would be acting in the downward direction, and this you can check by Fleming's left hand rule. So this force F will be equal to ILB. I is 5 by 2, L is 2, and B is 4 Tesla. So this is 20 Newton in the direction of minus J cap. So the correct answer will be option B. And obviously we could do this. We could assume a short wire or shortest wire only when magnetic field is uniform. So this is a uniform magnetic field, but it is a two-dimensional magnetic field. So we can assume this complete V-shaped wire as a single straight wire which is connecting the initial and final points, like that. So now let's move on the next question. In this question, you can see that a charged spherical capacitor consists of two concentric spherical shells A and B, and obviously B is greater than A. The half of the electrical energy stored of this system lies within the spherical region of radius R if. So first of all, let us analyze the situation. The first question that would arise in the mind of the students will be that whether this capacitor is grounded from inside or from outside, because in both the cases C is different and energy is different, obviously. But let me tell you that whenever it is not given that it is grounded from inside or from outside, by default you have to assume that it is grounded from outside, because this is the natural spherical capacitor. So if we give a charge Q to the inner capacitor and obviously its radius is A, then induced charge will be on the outer capacitor on the inner surface, and the charge on the outer surface will be 0, and there will be no electric field outside this region. Second thing is the most important thing, that electric field in this region will be storing the energy, because inside the smaller shell electric field is also 0. So the energy would be stored in this region only. And you definitely know that the electric field in this region is only due to the smaller sphere. There is no contribution in electric field by the bigger sphere in this region, obviously, because bigger sphere has 0 electric field inside it. So electric field in this region at a distance r will be kq by r square, and the energy density U is half epsilon naught E square. So if we substitute the value of E, and if we find out du, then du will be half epsilon naught E square will be k square q square by r to the power 4, and dv is the incremental volume, which is 4 pi r square dr. I hope this incremental volume you all know. So you can just cancel out the terms, and you can say that it would be kq square by 2r square dr. Okay, now first of all, if you calculate the total energy, then it would be kq square by 2, and integration of dr upon r square, limit will be from a to b, because the energy will be stored in this region only, so limit will be from a to b only, and this will be kq square by 2, and this is minus 1 upon r, so it would be 1 upon a minus 1 upon b. This is the total energy stored. Now if we find out the energy stored till r distance, so it would be half, in fact this is half kq square, and the limit will be from dr upon r square, and the limit will be from a to r. Then it would be kq square by 2, and it would be 1 upon r minus, in fact 1 upon a minus 1 upon r. So this energy is half of the total energy. So kq square by 2, 1 upon a minus 1 upon r is equal to 1 by 2 of kq square by 2, and it would be 1 upon a minus 1 upon b. So this is the energy, and cancelling kq square by 2, kq square by 2. So you can see that 2 by a minus 2 by r is equal to 1 by a minus 1 by b. So 2 by r is equal to 1 by a plus 1 by b, and therefore r is equal to 2ab upon a plus b. So the correct answer will be C. Now we move on the next question. In this question, you can see that there are two stars of masses m1, which is ms, and m2 is 15 ms, where ms is the mass of sun. Now these are forming a binary star system, which means they are revolving around their common center of mass, and the separation between them is 4 AU, where AU is astronomical unit, which is the distance of Earth from Sun. They are moving in the circular orbits about their common center of mass, and we have to find out the time period of revolution of each star. We have already discussed in the binary star section, you can find it in gravitational playlist, that the time period of the binary star is 2 pi under root of r cube divided by g m1 plus m2. Okay. And t, let us suppose that it is t dash is 2 pi under root of r cube is d cube, and d cube will be equal to, let us suppose that 1 AU is r naught. So it is 4 AU, so it would be 6, in fact 4 to the power 3. So 4 to the power 3 is 64 r naught cube divided by g, and m1 plus m2 will be equal to 16 ms. So t dash will be equal to 2 pi under root of 4 r naught cube by g ms, and therefore we know that the time period of revolution of Earth around the Sun is 1 year, which is 2 pi under root of r naught cube by g ms. This is 1 year. So obviously t dash will be equal to 2 years. So the correct answer will be option B. Now let us move on to the next question. In this question, you can see that the total energy released in alpha decay of stationary radium nucleus of mass is this, and alpha particle has a mass of 4 AMU is this. We have to choose the correct option for the recoil speed and recoil energy of the alpha particle and daughter nucleus. So let us first of all write down the reaction. So reaction would be radium will be decaying into radon, which is 222, and plus alpha particle and plus some energy, which is 4.9. So we know that the initial momentum of this radium is 0, and therefore final momentum would also be 0. So we can say that the momentum of this radon and the momentum of this alpha particle will be same, equal to P, and the kinetic energy is P square by 2m. Okay, so we can say that and mass is mass number A into AMU U. So we can say that kinetic energy of radon and kinetic energy of alpha particle is in the inverse ratio of masses. Mass of alpha upon mass of radon. And masses are in the ratio of atomic number. So the atomic number of alpha particle is obviously 4. So this is 4. And for this radon, it is 222. So kinetic energy of radon upon kinetic energy of alpha is 2 by 111. So the total energy Q can be divided into two parts. So kinetic energy of radon will be equal to 2 into 4.9 upon 113, and kinetic energy of alpha particle will be 111 into 4.9 upon 113. So I'll tell you that this value 2 into 4.9 into divided by 113. This is 0.086, and this value to 111 into 4.9 divided by 113. It is 4.81. So option A, which says that energy of recoil of daughter nucleus is nearly 8.7, it is wrong. And it is also in kilo electron volts, so it is wrong. Option B, which says that energy of recoil of daughter nucleus is 4.81 MeV, is absolutely correct. In fact, it is the energy of alpha, so it is not correct. The recoil speed of daughter nucleus is this, and the speed of alpha particle is this approximately. So if we find out the value of speed of alpha particle, so k alpha, kinetic energy of alpha particle is equal to half mass of alpha, which is 4 into 1.6 into 10 raised to power minus 27 into v square. And kinetic energy of radon is half into mass of radon will be this is given as mass, so we can take this mass as in fact you will be taking 222 u. U is 1.6 into 10 raised to power minus 27 into v square. So you would be getting the answer as C. You could check the answer by substituting the values. Now we move on the next question. In this question, you can see that there is an observer, a listener, which is at rest with respect to the ground and air, and he hears a sound of frequency f1 which is coming from a source which is moving towards him with the velocity of 15 meters per second. Okay, towards east. Now if listener is moving now towards the approaching source with a velocity of 25 meters per second towards west, then he hears a frequency f2 that differs from the f1 frequency by 40 hertz. So we have to find out the true frequency f produced by the source of sound. So we know that f1 is the frequency observed when only source was moving with the velocity of 15 meters per second towards observer. So the formula will be 340, which is the speed of sound, divided by 340 minus 15 into f. And f2 will be the case when both are moving towards each other. So this would be 340 plus 25 divided by 340 minus 15 into f. And obviously f2 is greater, so f2 minus f1 is 40. So f2 minus f1 will be equal to 25f by this is 340 minus 15, and it would be 325. That is 40. So this is 12 and 113. So f is equal to 520 hertz. So the correct answer is A. Now we move on the next question. In this question, you can see that there is a uniform rod of length L that swings from a pivot as a physical pendulum. Now the position of pivot can be varied along the length of the rod, and we have to find out the minimum time period with which the rod can oscillate about the mean position, and that minimum time period is t is equal to 2 pi under root L by G, where we have to find out the value of L. So let us first of all write down the formula of physical pendulum, which is 2 pi under root K square by D plus D upon G. Okay, so this is the formula of physical pendulum, and for minimum time period, T minimum, for T minimum, K should be equal to D. So T minimum will be equal to 2 pi under root, this is 2K by G, and K is radius of gyration of rod, and it is L by 2 root 3. So T minimum will be equal to 2 pi under root L by root 3 G. So this capital L will be L by root 3, small l by root 3. So this is the correct answer. Now we move on the next question. In this question, you can see that the number density of conduction electrons in a pure silicon crystal at room temperature is about 10 to the power 16 electrons per meter cube. The number density of the conduction electrons is increased by a factor of 10 to the power 6 by doping silicon lattice with phosphorus. Now assume that at room temperature every phosphorus atom contributes 1 electron to the conduction band. Then we have to find out the fraction of silicon atoms replaced by the phosphorus atoms in the crystal. Given that the density of the silicon is this and molar mass of the silicon is 28.1 grams. Let us first of all derive the final expression in terms of variables. So we can see that the final electron density is final electron density is 10 to the power 22 electrons per meter cube, and the mass of molecular mass of silicon is this, and the density of silicon is this. So we know that density is equal to mass upon volume. Okay, and we can say that molecular mass is mass of mass of a silicon atom multiplied by Avogadro number. This is the molecular mass. Okay, so we can say that mass of a silicon atom will be m upon Avogadro number, and total mass of silicon atom, small m, silicon crystal, will be n into mass of one atom. So it would be equal to n, where n is the number of silicon atoms present in the crystal, into mass of one atom is m by Na. And density is rho is equal to m by v, so n m by Na into v, and this n by v is called as number density. So let us number density of silicon atoms. So this is number density of silicon atoms. So n is equal to rho Na divided by m. This is the value of small n, number density of silicon atoms. And we can see that each phosphorus atom replaces one silicon atom, and by doping the phosphorus, the number of electrons has increased by this much amount in the crystal. So we can say that the number of phosphorus n, the number of phosphorus doped per unit volume will be equal to, n will be equal to 10 to the power 22, which is the electron density because each electron is contributed by one phosphorus. So the fraction of silicon replaced by phosphorus will be 10 to the power 22 upon total silicon, which is rho Na by m. So by using the given values, m is this, Na is the Avogadro number, rho is the density in standard units. The value of this number, fractional number of silicons replaced by the phosphorus will be 2 into 10 raised to power minus 7, which is the option B. So now we move on the next question. In this question, you can see that there is a soap bubble of radius 10 centimeter, and this is a hollow soap bubble. Obviously bubble is hollow, and therefore the thickness of the film of the bubble is 10 by 3 into 10 raised to power minus 6 centimeters. This bubble is charged to a potential of 80 volts, and this bubble gets bursted completely and gets converted into a spherical drop, single spherical drop. Assuming that this soap solution is a good conductor, the potential of the surface of the drop will be. Now we know that this is R1. Let us suppose that this is R1, and the potential V1, which is this one, V1 will be equal to KQ by R1. Okay, and now we know that this bubble has a volume, solid volume, in which the soap solution liquid is filled, is V is 4 pi R1 square into this thickness T. This is the volume in which the liquid is filled in the bubble, obviously, and when this volume is converted into a solid spherical drop, then the radius of the drop will be 4 by 3 pi R2 cube. So cancelling 4 pi and 4 pi, R2 cube will be equal to 3 R1 square T. Okay, so this is R2 cube, and R2, now we know that the volume, the charge remains the same, because all the charge will be carried to the single spherical drop. So new potential V will be KQ by R2. So V1 by V2 will be equal to R2 by R1, and you can see that if we multiply, or this is R2, so R2 will be equal to 3 into R1 square. Now R1 square will be equal to, we are not converting the units, we are just using the centimeter only. So R1 square is 10 to the power 2, and T1 is 10, I'll write it down here. Yeah, R2 will be equal to, R2 cube will be equal to 3 into R1 square, which is 10 to the power 2, and T will be 10 upon 3 into 10 raised to power minus 6. Okay, so R2 cube will be equal to 10 to the power, this is minus 3. So R2 will be equal to 10 to the power minus 1. Okay, so it is 1 by 10. Okay, now R2 is 1 by 10 and R1 is obviously 10. So we can say V1 by V2 will be equal to 1 by 100. So V2 will be equal to 80 into 100. So V2 will be equal to 8 kilovolts. So the correct answer is D. Now let us move on the next question. In this question, you can see that there are 3 resistances, each of 4 ohms, and each is being rated with 16 watt of power. Now these resistances are connected with this cell of potential difference V, which is applied between points A and B. So we have to choose the correct option. So first of all, let us examine the first statement, which says that the maximum potential difference that can be applied is 12 volts. So let us see first of all that this combination is 2 ohms and this is 4 ohms. And if we have to divide this 12 volts into 2 and 4, then we know that the ratio division is a simplest trick to divide the potentials, and the ratio of 2 and 4 is 1 is to 2. Adding that ratio, it would be 3, and dividing 12 with 3, and the one part would be 12 by 3, which is equal to 4. Now this is 4 obviously, and this voltage will be 4 volt and this will be 8 volts. Now let us see that the power loss in this one will be 8 square upon 4. So power loss will be 64 upon 4, which is 16, and the power loss across each one of them is P is equal to 4 square upon 4, that is 4 watts. So we can see that when we use V as 12 volts, the maximum power has been reached on this resistance. Therefore, we cannot apply a voltage which is greater than 12, because in that case the power across this resistance would exceed 16 watt, which is the maximum rated power. So we can say that the maximum potential difference that can be applied is 12. So statement 1 is correct. And the maximum power dissipated. Now if the voltage applied is maximum, then automatically the power loss in the circuit will be maximum. So P max will be now equal to the sum of power losses across these three resistances. So this is 16 and this is 4 plus 4. So it is 24 watt. So the correct answer is the fact that both statements are correct. So D is the correct answer. Now we move on the next question. In this question, it is given that there is a beaker which is containing a cylindrical beaker which is containing some water. This beaker is being rotated about its axis like that, and this surface of the water forms some shape. Now we have to identify the name of the shape that this water surface will form. So first of all, let us see that at this point we know that if this distance is r, then the particle which is situated on the surface of the water will be experiencing a force of m r omega square and mg in the downward direction. Now net force will be like that, obviously F net, and at this position this angle is theta, this is 90 minus theta, and this is theta. So tan theta will be now equal to r omega square by g, and tan theta is obviously dy by dx, which is the slope, and x is r, so x omega square by g is dy by dx, and dy will be equal to x dx integration into omega square by g, and the limit of x will be from 0 to x and 0 to y. So y will be equal to x square omega square by 2g. So this is a parabola, which means that the two-dimensional shape of this surface will be a parabola, and the 3D form of the parabola is obviously paraboloid. So the correct answer is C. Now let us move on the next question. In this question, there is a sphere, uniformly charged non-conducting sphere, which has a cavity like that, and the sphere has uniformly distributed positive charge, and the charge density of the sphere is rho. So there is a spherical cavity here, and the center of the cavity is O, and the center of the bigger sphere is C. So the electric field inside the cavity will be. So we know that this cavity has a uniform electric field which is pointing in the direction of CO. This is. So this will be the uniform electric field and it is not radial. So the answer will be B. Okay, now we move on the next question. In this question, you can see that there is a cylindrical tank which has a base area of A, capital A, and it has a small hole in the base out of which the water is leaking, and initially the level of water was H in the cylinder. Now the area of that small hole is small a, and the velocity of efflux, which is the velocity with which water is coming out of that hole, is under root 2gh initially, because initially the height of liquid column is h above the hole. Now when after some time the level of water will obviously decrease, and at some time the level is, let's suppose, y. Okay, so at some time the level of water remaining in the beaker is y. So the velocity of efflux of liquid coming out will be under root 2g y, and let us suppose that this is the scenario at time t, and after a small incremental time dt, a small decrement in the length of the liquid column occurs, which is y, dy. So we can say that by using equation of continuity, a1 v1 will be equal to a2 v2. Okay, now you can see that a is the area, this area a, and v is the velocity with which this level of water is going down. So it is dy by dt with a negative sign. This negative sign indicates the fact that y is decreasing, and this is equal to a, small a, into v2, which is root 2gy. So let us integrate it. So dy upon root y will be equal to dt with a negative sign, and let us use all the other terms in C as a constant. So now you can see that C, the integration will be C into 2 root y, and the limit will be from h to y, and this is minus t. And by that minus sign we can interchange the limit, and t will be equal to 2c under root of, this is root of h minus root of y. So now initial time was t, and that t time was the time taken by the water level to decrease from h to h by 2. So t will be equal to 2c root h minus root h by 2, and t dash will be the time for water level to decrease from h by 2 to 0. So it would be h by 2 minus 0. So t upon t dash will be equal to under root of h minus root of h by 2 divided by root of h by 2. So this will be root 2 minus 1, and this is t dash will be equal to t upon root 2 minus 1, which means that if we rationalize it, so t dash will be equal to t into root 2 plus 1. So the correct answer will be D. Now let us move on the next question. In this question, you can see that OABC is a regular tetrahedron. Each side of this tetrahedron is made up of a wire which has a resistance of 4 ohms per meter, and the length of each side is 2 meter, which means that resistance of each side, this is resistance of each side will be equal to 4 into 2, which is 8 ohms. Okay, and M is the midpoint of this side BC. The resistance, equivalent resistance between O and M. So let us assume that this OBC is the base, equilateral base, and this is the apex point of the tetrahedron. So if we draw a plane which is crossing this, which is cutting this tetrahedron symmetrically, passing through O and M, so you can see that the potential of B and potential of C will be equal. VB will be equal to VC, which means that we can join these two, and let us join these two first of all. So let us fold and let us join B and C. So this will be the scenario. Now this resistance, this one will be 8 by 2, which is 4. This one will be still 8 because this is not because this resistance, this is in parallel with AC. AB is parallel with AC. So AB and AC combinedly forms a 4 equivalent of 4 ohm, and this OB is parallel to OC. So it would be 4, and this half resistance is 4, and when we will combine B and C, MB and MC will be in parallel. So 4 and 4 is 2. So this will be 2. Now we remove this mirror. Now we remove this mirror like that. Okay. So this will be the situation. Now you can see between M and O, if we have to find out the equivalent resistance. So you can see that 8 and 4 are in series. So this is 12, and 12 and 4 are in parallel. So this has a equivalent resistance of 12 into 4 upon 16. So this is 3. Okay, and this 2 is in series with this 3. So the total R equivalent will be 5 ohms. So the correct answer is A. Now we move on the next question. In this question, we can see that there is a box of weight W that is placed on a rough horizontal force. The floor. The coefficient of static friction between the box and the floor is mu. And to move this box, we have to apply a pulling force F by a rope or something else at an angle of theta. So we have to find out the minimum force F that can move this block. So first of all, let us see that there will be two components of this F. The first one, you can also see the same concept in the playlist of friction, and I can also tell you the direct answer, but let us derive this situation. So this is F cos theta and this is F sin theta. W is acting in the downward direction and friction is acting in the backward direction, and this is the normal reaction. So normal reaction will be equal to W minus F sin theta, and the maximum friction which can act on this block will be mu n. So it would be mu into W minus F sin theta. And to move this block, F cos theta should at least be equal to F max. So F cos theta should be equal to mu W minus mu F sin theta. So F is common, so this is cos theta plus mu sin theta is equal to mu W, and therefore this F will be equal to mu W by cos theta plus mu sin theta. Now to minimize this force, let us differentiate this force with respect to theta. So dF by d theta will be mu W, and cos theta, this is cos theta plus mu sin theta whole square, and with a negative sign, and differentiation of cos theta is minus sin theta, plus differentiation of sin theta is cos theta. So this is mu cos theta, and that is equal to 0. So you can see that mu is equal to tan theta. Okay, so we can replace the value of theta by tan inverse mu. So F minimum will be mu W divided by under root of, in fact, divided by, this is cos theta plus mu sin theta. So if tan theta is mu, so cos theta will be 1 upon under root of mu square plus 1, and sin theta will be equal to mu upon under root of mu square plus 1. So this is cos theta, which is 1 upon under root of mu square plus 1, and sin theta is mu square upon under root mu square plus 1. This mu square is due to the fact that there is already a mu here. Yeah. So you can see that F minimum will be equal to mu W by under root of mu square plus 1. So the correct answer will be equal to C. Okay, and this is the complete derivation of this. Now let us move on the next question. In this question, you can see that there is a room whose wall is having a dimension of 2:3 meters, and it consists of layers of white pine of thickness 2 centimeter and a layer of rock wool of some thickness. Now the external temperature is 36 Kelvin below the indoor temperature of the room, and the conductivity of white pine is 0.1 and the rock wool conductivity is 0.04. So the thickness, we have to find out the thickness of rock wool so that the thermal conduction rate dQ by dt is 120 watt. Okay, so obviously we can easily say that the walls, this is thickness D and this is of thickness T, which we have to find out. So this is white pine and this is rock wool. So the equivalent resistance of this wall will be R1 plus R2, and R1 will be equal to D upon A, which is D upon KA, K1A, area of the wall, and R2 will be equal to T upon K2A. So R equivalent will be equal to 1 upon A is common, D upon K1 plus T upon K2. Now dQ by dt is equal to dt by dt. In fact, it is equal to dt by R, where R is the equivalent resistance. So dQ by dt is 120, and this is equal to dt, which is 36, divided by R equivalent, and R equivalent will be D by K1 plus T by K2. Okay, so you can see that D by K1 plus T by K2 will be equal to 36 into A by 120, and this we will simplify further. So D was 2 centimeters, so let us use D in standard unit, which is a meter, so it would be 0.02 meters, divided by K1. K1 is the pine, so it would be 0.1, plus T, which we have to find out, is T, and K2 is rock wool, and it would be 0.04, and this is equal to 36 by 120 into area. Area is 3 into 2, 6. So this is 20, and this would be equal to 9 by 5. So this is 0.2 plus T by 0.04 will be equal to 9 by 5, and 9 by 5, let us use another page. T by 0.04 will be equal to 9 by 5. 9 by 5 is 1.8 minus 0.2. So t divided by 0.04 will be equal to 1.6. So t will be equal to this is 16 into 4 into 10 raised to power minus 3. So it would be equal to 0.064 and 0.064 meters. So in centimeters it would be 6.4 centimeters. So the correct answer is B. Now let us move on the next question. In this question you can see that there is a 240 kg block that is suspended from a fixed point O with a string of length 13 meters, and the rope is massless, string is massless. A horizontal force F, which is a constant force F, is applied on the block in such a way such that block moves very slowly from this position to this position. So obviously now D is given as 5. So this is this length is 13 meter, and in fact it is not given that force is constant, which means that we cannot take the force as constant, and block is being shifted slowly, which means that at each point of time the velocity of block is negligibly small and the block is in equilibrium. Now the block remains stationary in this position, and we have to find out the value of F is in this position. And first of all, let us see that this angle is theta, and if this is t, then this is t cos theta and this is t sin theta. So t cos theta is balancing mg, which is 240g, and t sin theta is equal to F. So tan theta is equal to F upon 240g. And tan theta, you can see that from this triangle, tan theta is this upon this. So this will be obviously 12 and this is 5, so this is 13. So tan theta will be equal to 5 by 12, and therefore F will be equal to 100g. So the value of 100g will be 980 newtons. So A is correct, statement 1 is correct. But if F was constant, if F is constant, so we can see that the work done by F was F into this displacement, but F is not constant and F is variable, but the block is moving in such a way such that the velocity is negligibly small, it is almost zero, and at all the points block is in equilibrium, which means that the work done by F will be equal to the work done against mg plus work done by T. Now work done by T will be 0 because tension is radial force, it is always acting in the radial direction, so its work done will be 0. So work done by F will be equal to work done against mg, and it would be equal to mgh. Now h in this case is equal to 1 meter, and therefore m is 240, g is 9.8 and this is 1. So the work done W will be equal to 2352 joules. So the correct answer is statement 2 is also correct. So we can say that both statement 1 and 2 are correct. Now we move on the next question. In this question, you can see that the number of radioactive nuclei N for a radioactive sample are experimentally measured as the function of time t. At t is equal to 0, it was given that N was 50,000, and at t is equal to 10 seconds, N was equal to 5,000 plus minus 100. So the half-life of the sample is estimated by using these measurements, and we have to find out the error in estimation of half-life of this sample. So we know that N is equal to N naught e to the power minus lambda into t, and we know that lambda is ln2 by t. ln2 is 0.693. Okay, so n is obviously given as 5000 and n naught is given as 50,000. So what we'll do, we'll first of all differentiate n. So dn will be n naught, and you should always remember that here the variable is t, not small t. So n is equal to n naught e to the power minus ln2, and t time is 10 seconds by t. So dn will be equal to n naught into differentiation of this. So differentiation of this will be minus ln2 into 10 divided by t square into minus dt, cancelling this minus with minus, and e to the power minus ln2 into 10 by t. Okay, so this is the value of dn, and this complete value e to the power, this one, e to the power minus ln2 10 by t, can be replaced by n by n naught, or we can just say that n naught into this is n. So dn by n will be equal to 10 ln2 upon t square into dt. Now dn is 100, n is 5000, and dt is needed to be calculated, and t can be calculated by this data. So n is equal to n naught e to the power minus ln2 into 10 by t. So n is 5000, n naught is 50,000, e to the power minus ln2 into 10 by t. So by this equation, what you can do, you can take, I'll solve a bit. This is 5000 by 50,000 is 1 by 10, and this is equal to e to the power minus ln2 into 10 by t. Okay, and 10 is equal to e to the power 10 ln2 by t, and taking log both sides, so it would be ln 10, and this is 10 ln 2 by t. Okay, and ln 10 is 2.303, and this is 10, and ln 2 is 0.693 divided by t. So t will be equal to 6.93 divided by 2.303. So you can find out the value of t, and you can substitute the value of t here, and dn and n here. So there is no option that is matching with the correct answer. So I guess this would be the bonus question. Let's see in the answer key. Now we move on the next question. In this question, you can see that a gas, which is an ideal gas, is given a heat of 10.61 joules, and the pressure is kept constant, and the P pressure is 1.01 into 10 raised to power 5 pascals. The heat given is 10.61 joules, and delta V is the change in volume, which is 30 into 10 raised to power minus 6 meter cube. So first of all, let us find out the value of delta T, and therefore we know that P delta V will be equal to NR delta T. So P is 1.01 into 10 raised to power 5, and delta V is 30 into 10 raised to power minus 6, and this is equal to NR delta T. Okay. Now you can see that this is 3.03 into 10 raised to power 0, which is cancelled, and therefore it is equal to NR delta T. Now we know that Q is equal to NCP delta T, and Q is 10.61 NCP. CP is F by 2 plus 1 into R, and delta T is delta T. So NR delta T is 3.03. So F by 2 plus 1 is equal to 10.61 upon 3.03, which is approximately 7 by 2. So F by 2 plus 1 is equal to 7 by 2. This is 2. And F by 2 is equal to 5 by 2. So F is equal to 5, and hence we can say that the gas is diatomic gas. Now let us move on the next question. In this question, you can see that a ball is projected from this point O with a velocity u at an angle of theta, and this ball reaches this point P, which is at a horizontal distance of L and a height of h. So at this point, the velocity of the ball is v at an angle of alpha. So we have to find out the value of alpha in terms of h, L and theta. So first of all, let us use the trajectory equation. We know that trajectory equation is y is equal to x tan theta minus half g x square upon u square cos square theta. Now y at that point is h and x is L, capital L, and this is tan theta minus half g L square upon u square cos square theta. Taking out L common, so h by L is equal to tan theta minus gl upon 2 u square cos square theta. Okay, so gl upon 2 u square cos square theta will be equal to tan theta minus h by L, and gl upon u square cos square theta is equal to 2 tan theta minus 2h by L. Now let us differentiate this equation and we find out the slope. So dy by dx is tan theta minus g into x is L obviously, upon u square cos square theta, and we can substitute this value here. So dy by dx is the slope of this graph, which is minus tan alpha, and minus is due to the fact that this angle is below the x-axis. So minus tan alpha is equal to tan theta minus this thing, which is 2 tan theta plus 2h by L. So you can see that tan alpha will be equal to tan theta minus 2h by L. So the correct answer will be C. Now let us move on the next question. In this question, you can see that there is a chain which is a flexible chain which is of length capital L, and the mass per unit length of this chain is lambda. This chain is kept on a frictionless table, horizontal table, and the initial hanging length of the chain is y0 over the table. Now chain is at rest and this chain is let free. So the velocity of the chain when this chain will become vertical will be. So we know that obviously in this situation this is y0, and the initial potential energy considering this as ground will be negative, because it is the potential energy of the chain which is kept on the table will be 0, but the potential energy of this part of the chain will be negative because it is beyond the reference line, below the reference line. This depth, which is the depth of center of mass, is y0 by 2, and the mass of this part is lambda y0, and the depth of center of mass is y0 by 2 into g. So this is the initial potential energy of the chain. Now finally you can see that this chain is completely below this table. So finally the center of mass of the chain will be at a distance of L by 2 below the top point, and therefore the final potential energy of the chain will be minus of lambda L into G into L by 2. So this will be lambda L square G by 2 with a negative sign. And obviously the potential energy of the chain would decrease because the kinetic energy is increasing. So we can say that delta U, which is the decrement in the potential energy, will be U initial minus U final. And U initial minus U final will be lambda L square G by 2 minus lambda G by 2 Y naught square. And this is lambda G by 2 L square minus Y naught square. And that is equal to half mv square. And m is lambda L and this is v square. So cancelling this 2 with 2 and lambda with lambda, v will be equal to under root of G L minus Y naught square by L. So the correct answer will be option number A. Now we move on the next question. In this question, you can see that there is a Keplerian telescope that is adjusted for normal setting for parallel rays. Now normal setting means that the final image is at infinity. Now it is given that the mounting frame of the objective lens, which is, let us suppose that this is a mounting frame on which this lens is mounted. This mounting frame has a diameter of d. This is d, and the image of this diameter formed by the eyepiece is having a diameter of small d, which means that if we will form the image of this diameter like that, so this will be small d. Now we know that in normal adjustment gamma is FO by FE, and this distance will be FO and this will be FE. Now this angle is equal theta, so tan theta will be d by 2 upon FO, and tan theta will be small d by 2 upon FE. And when we will equate these two, then d by FO will be equal to d by FE. So FO by FE will be equal to capital D by small d. So the magnification of this telescope in normal adjustment will be d. Now we move on the next question. In this question, you can see that this is a circuit, AC circuit, which is having a voltage of 5 sine omega t, and the resistance value, the value of resistance R is this, and inductance L is this, and the value of capacitance C is 1 microfarad. So it is given that when either S1 is closed or either S2 is closed, both are not closed simultaneously. So when either S1 is closed or either S2 is closed, the peak value of the current in the circuit is same. So which means that peak value I max is V naught, which is 5 in the circuit, divided by Z1, and again I max is 5 upon Z2. So Z1 is equal to Z2, and Z1 is the impedance when switch S1 is closed only. So this is a RC circuit. So Z1 is under root of XC square plus R square. And when S2 is closed and S1 is opened, this is a LR circuit, and Z2 is under root of 4R square plus XL square. Okay, so this XC square plus R square is equal to 4R square plus XL square, and 3R square is equal to XC square minus XL square. This is equal to 3r square. And 3r square is xc square. Xc square is 1 upon omega c, omega square c square, and xl square is omega square l square. So this r is this one, and this is 9 into 10 raised to power 6, that is equal to 1 upon omega square, and this is 10 raised to power minus 12. Okay, and this is in fact this is, yeah, so minus omega square, and L square is 4. So you can see that if we write it down, so it is 9 into 10 raised to power 6 is equal to 1 upon omega square into 10 raised to power 12 minus 4 omega square. So I will take the LCM. So 4 omega to the power 4 minus 10 to the power 12 and plus 9 into omega square into 10 raised to power 6 is equal to 0. So this is a quadratic equation, and to solve this equation, let us assume omega square. So let us directly write down the value of omega square. So it is minus b. So minus b is minus 9 into 10 raised to power 6. So minus 9 into 10 raised to power 6 plus, obviously we cannot take the negative root. So plus b square, which is 81 into 10 raised to power 12 and minus 4ac. So it would be plus, and 4ac will be 4 into 10 raised to power 12 into 4. So it would be equal to 16 into 10 raised to power 12 divided by 2a. Now 2a will be 8. So omega square is, this is minus 9 into 10 raised to power 6 plus this is root of 97 into 10 raised to power 6 by 8. Root 97 is approximately 9.8. So it would be 0.8 into 10 raised to power 6 by 8. So it would be 10 raised to power 5. So omega will be equal to root 10 into 10 raised to power 2. And omega is 2 pi f. So root 10 is pi. So f will be 50 hertz. So the correct answer will be 50, but it is not mentioned in this option. So you can say that it would be bonus question. So now we move on the next question. In this question, you can see that there are two physical quantities, A, which is equal to F upon rho V square D, and B, which is equal to rho Vd by neta, where F is force, rho is density, D is diameter, V is velocity, and neta is coefficient of viscosity. So we have to find out that which of the following quantity is dimensionless. So first of all, let us analyze quantity A. So it is F upon rho V square D. Now you know that obviously the unit of force is kg, meter per second square. This is force. Okay, and rho is density, so it is mass per unit volume, so it is kg, and volume is meter cube, and v is the velocity, so it is meter square upon second square, and d is the dimension, which d is the diameter, which is meter. So cancelling this with this, and second square with second square, kg with kg, and you can see that this meter is left over, so this is not a dimensionless quantity. The dimension of A is equal to the dimension of length. And now let us talk about B. So B is rho V D upon neta. Now neta is the coefficient of viscosity, which is F upon, you know the formula that F is neta A dV by dz. Okay, so F is the force, so F upon A dV by dz. This is the dimension of this neta, and you can say that neta is, this is force, and you can cancel the dimension of dz with dv, and there would be a second on the numerator, and here it would be meter square. So dimension of neta is this. So dimension of b will be rho vd. Rho is kg per meter cube, and v is the velocity, obviously. So it is meter per second, and d is the diameter. This is meter, and neta is force second per meter square. So neta is in the denominator. So force is kg meter per second square. This is force, and second per meter square, so it would be second per meter square. So you can see that second square is cancelled with second square, and this is meter to the power 4, meter to the power 4 is cancelled, and kg is cancelled with kg. So quantity B is dimensionless. So correct answer is B. Now let us move on the next question. In this question, you can see that there is a uniform string of length L. Let us draw the string, and mass of the string is m. So it is supported by a rigid support from the top, and a transverse pulse is allowed to propagate down the string from the starting point. At the same time, a ball of mass m is dropped from the top of the support, and this ball will overtake the pulse at a distance of x from the top, and we have to find that distance x. So we know first of all that at a distance of x from the top, the speed of the pulse v will be under root of L minus x into g. This result is already being derived in the waves. So this is the velocity of the pulse, and the acceleration of the pulse is dv by dt. So dv by dt will be root of g into 1 by 2 under root of L minus x into minus of dx by dt, and a will be equal to under root of g by 2, and this is L minus x root L minus x, and multiply by dx by dt is velocity v, and there is a negative sign. V is this, so this will be minus of root g by 2 under root of L minus x into v is under root of L minus x into root g. So cancelling this L minus x with L minus x, so this is minus g by 2. So the acceleration of the wave is in the downward direction. In fact, is in the upward direction, because we have considered the downward direction as positive. So acceleration of the wave is in upward direction. So wave is retarding as it is going down. So this is the acceleration of the wave, and the acceleration of the ball, this is acceleration of pulse, and acceleration of ball is plus g in the downward direction. So now let us see that relative acceleration, A relative, of pulse with respect to ball, or ball with respect to pulse, is A ball minus A pulse, which is 3g by 2, and u initial of the pulse at the top point is under root of Lg. You can substitute the value of x as 0 at this point to find out the velocity of the pulse at this point. So this is under root Lg, and u initial of the ball is 0. So u of ball with respect to pulse initially is minus of root Lg, and the the initial displacement of the s initial relative of the ball with respect to pulse is 0, and s final relative of the ball with respect to pulse is 0. So delta S relative is 0. So we are finding out the time in which this ball will overtake the pulse. So we are using S relative, delta S relative is U relative T minus or plus half G or A relative into T square. So S relative is 0, U relative is minus of root Lg, T is the time, plus this is half into 3 by 2 G into T square. So T will be equal to 4 by 3 under root of, in fact, so under root of L by G. So this is the time when this ball will overtake the pulse, and in this time the displacement of the ball, S ball, will be half gt square. So this is half g, t square is 16 by 9 and this is L square by g, in fact L by g. So cancelling this g with g, so this is 8L by 9. So the correct answer will be B, 8L by 9. Now we move on the next question. In this question, you can see that this is a positron decay reaction, and in this reaction C, which is the carbon, is decaying into this is boron and this is positron and this is a photon. So we have to find out the Q value of this reaction. So obviously we know that Q will be equal to delta mc square, and delta m is the mass defect of this reaction. In fact, the difference of mass of reactant and product. So it is mass of this C11 minus mass of boron 11 plus mass of positron. Okay, and the mass of C11 is 11.01142 minus this is mass of boron, which is 11.00931 plus positron, which has a mass of 0.00055. Okay, and this is delta m. So this delta m will be equal to 0.00156, and therefore we know that the energy by 1 AMU is 931 mega electron volt. So energy by this much mass will be 0.00156 into 931 MeV. So it is 1.45 MeV. So the correct answer is A. Now let us move on the next question. In this question, you can see that two mechanical waves, y1 is equal to A sine 8x minus 50t, and y2 is equal to A sine 8x plus 50t plus pi by 3, are traveling in opposite directions along the x-axis, and they superimpose on each other. Now the position of node which is nearest to the origin will be. So obviously y1 is A sine 8x minus 50t and y2 is A sine 8x plus 50t plus pi by 3. Okay, so when they will be superimposing on each other, then y resultant will be equal to y1 plus y2, and therefore this is the formula of sin A plus sin B, and sin A plus sin B is 2 sin A plus B by 2 cos A minus B by 2. So this is 2A sin A plus B by 2. So it is 8x plus pi by 6 and cos A minus B by 2, which is 50t plus pi by 6. So this is the amplitude, variable amplitude with displacement, and A as a function of x is 2A sine 8x plus pi by 6. So we know that at node, this is 0 at node, so this is 2a sine 8x plus pi by 6, which means that 8x plus pi by 6 is equal to pi. So 8x is equal to 5 pi by 6. Okay, and x is equal to 5 pi by 48, and it is equal to 0.327 meters, and x in centimeter is 32.7 centimeter. So the correct answer is A. Now let us move on the next question. In this question, you can see that at a certain location on Earth's surface, the intensity of sunlight is 1 kilowatt per meter square. A perfectly reflecting concave mirror of radius of curvature r and aperture radius small r is facing the sun to produce the light of intensity 100 kilowatt per meter square at the image. Knowing that the disk of the sun subtends an angle of 0.01 radians at the Earth's surface, we have to find out the relation between capital R and small r. So let us draw the scenario. Let us see that this is the sun and this is a small concave mirror as compared to the sun. This is the radius of curvature, radius of aperture of the mirror, and the sunlight is falling on the mirror like that, and mirror is reflecting this sunlight and focusing it on the focus of the mirror like that. Now you can see that if this is r dash, radius of the image formed at focus, and this distance is f, and this is the half angle of the sun, which is theta by 2. Theta is 0.01 radians. So you can see that the intensity at this mirror, which is on the earth, is this one, 1 kilowatt per meter square, and we know that intensity is inversely proportional to the square of area, in fact square of radius. So I1 by I2 will be equal to r square, in fact r dash square upon r square. What is this? This is the intensity of sunlight at the concave mirror and the intensity of sunlight at this image. So at concave mirror it is 1 and at image it is 100, and r dash upon r square. So r dash is equal to r by 10. First of all, this is the relation. Now we know that this angle will be theta by 2, and again this angle will be theta by 2, same. So you can see that by this relation you can see that the value of r dash is can be written as r dash is equal to f theta, where f is the focal length and theta is the small angle, that is theta by 2. So r dash is the radius of this image. So r dash will be equal to f is r by 2 and theta by 2 is 1 by 2 into 0.01. So r will be equal to capital R, small r will be equal to 10 r dash. R dash is r by 4 into 0.01. So r is equal to 0.1 r by 4. So capital R is equal to 40 small r. So the correct answer should be C. Now let's move on the next question. In this question, you can see that a Q charge is being uniformly distributed throughout the volume of a non-conducting sphere of radius r. Now we have to find out the total electrostatic energy of electric field which is stored inside the sphere. Okay, so what we can do, we know that the self energy of a solid sphere U is equal to 3 by 5 kq square by r, And the self energy of hollow sphere, this is solid sphere and this is hollow sphere, is kq square by 2r. Now we know that the electric field formula for the solid sphere and hollow sphere outside the spheres is same. Therefore, the energy stored outside both the spheres is same, and therefore if we wish to find out the energy stored inside the sphere, then we can obviously just subtract these two energies, and it would be 3 by 5 minus 1 by 2, and this is kq square by r. So it would be equal to 1 by 10 kq square by r. So the value of alpha is 1 by 10. So the correct answer is D. Now we move on the next question. In this question, you can see there is a long straight wire of circular cross section, and the radius of cross section is r, and it contains n conduction electrons per unit volume. So electron density is n. Now current flowing in the wire is I. Let us suppose that from the cross section it seems that current is going inside the wire, along the wire, and we have to find out the magnetic force acting on any electron which is situated on the surface of the wire. So first of all, let us find out the magnetic field on the surface of the wire, and the direction of magnetic field will be in the downward direction. So B will be mu naught I by 2 pi r. We know this formula on the surface of the wire, and we can say that electron will be coming out of this plane because current is going inside. So electron will be moving outwards with the drift velocity, and therefore the force acting on the electron will be QVB. Q is E, V is Vd, and B is mu naught I by 2 pi r. Okay. So now drift velocity is outside this plane. Then you can apply the Fleming's left hand rule, and you can check that the force will be acting in the inward direction, and this force Fe will be mu naught I by 2 pi r into EVD. Now we know that I is equal to NEAVD. So EVD is equal to I upon N into A, which is pi r square. So we can substitute this value. So it would be mu naught I square divided by 2 pi N, and this is pi square r cube. And this would be acting in the inward direction. So the correct answer will be C. Now let us move on the next question. In this question, you can see that in Young's double slit experiment, a bright fringe is observed at a height of 1.5 centimeter from the central maxima, or center of the screen, which is 3 by 2 into 10 raised to power minus 2. Okay, and we know that it is given that lambda is 612 Newton, in fact nanometer, which is 10 raised to power minus 9 meters, and capital D is 1.4 meter, and small d is 4 into 10 raised to power minus 4. So we have to find out the number of dark fringes which is present in between this bright fringe and the central maxima. So for that we have to find out the order of this bright fringe, and y is equal to n lambda capital D by small d, and y is 3 by 2 into 10 raised to power minus 2. Now n will be equal to 3 by 2 into 10 raised to power minus 2 into small d by lambda capital D. So n is 3 by 2 into 10 raised to power minus 2. Small d is 4 into 10 raised to power minus 4, and lambda is 612 into 10 raised to power minus 9, and capital D is 1.4. So by putting these values, n will be equal to 7, and obviously we know that there will be 7 minima in between these 7 maximas, because the order of minima is advance by maxima. We know that just after the central maxima, first minima occurs and then first maxima occurs. So we can say that just below the 7th maxima there would be 7th minima. So we can say that total 7 minima are present between central maxima and 7th maxima. So C is the correct answer. Now let us move on the next question. In this question, you can see that an illuminated point object is placed in the front of a lens, whose equiconvex lens, whose mu is 3 by 2, and obviously R1, R2 are equal, and the focal length of the lens is given as 40. Now a liquid water is filled behind this lens till a distance of 40 centimeter, and we have to find out the position of final image formed. So first of all, we know that the final image will be formed after 3 refractions. First refraction would be from this surface, second refraction would be from this surface, and the third one will be from this surface. So we know that 1 by f is equal to mu minus 1 into 1 into this is 2 by r. 1 by r1 minus 1 by r2 will be 2 by r, because r2 is negative. So 1 by f, for this lens mu is 3 by 2 minus 1, and this is 2 by r. So for this lens f will be equal to r, and it is 40, so f r is equal to 40. So for first refraction, obviously mu 2 by v minus mu 1 by u is equal to mu 2 minus mu 1 by r. So this is the formula: mu 2 by v minus mu 1 by u is equal to mu 2 minus mu 1 by r. So mu 2 is 3 by 2, v is v1 minus mu 1 is 1, and the object is placed at 120 centimeter in front of the lens. So it would be plus 120, and that is equal to 1 mu 2 minus mu 1, which is 3 by 2 minus 1 upon r is 40. So v1, 3 by 2 v1, this I'll use the next page. So 3 by 2 v1 will be equal to 1 by 80 minus 1 by 120. 1 by 80 minus 1 by 120. So the LCM will be 240, and this will be 3 minus 2. So this is 3 by 2 v1, and this v1 will be equal to 3 by 2 v1 will be equal to 1 by 240, and this is 120. So v1, this is v1. So v1 will be equal to 360. And now v1 is 360, which means that the image of first refraction is at a distance of 360. And now that image will be the object for second refraction. And for second refraction, we again use the spherical refracting surface formula. So for second refraction will be u will be equal to plus 360. So mu 2 is 4 by 3, v2 minus u is obviously u is behind this surface, therefore it would be positive for this refraction also. So u will be minus mu1 is 3 by 2, u is 360, is equal to mu 2 minus mu1, which is 4 by 3 minus 3 by 2, divided by r. Now as incident rays are moving in this direction, and we are measuring the r of this surface in this direction. So r would be negative, so it would be minus 40. So r would be minus 40. So 4 by 3 V2 minus this is 1 by 240 will be equal to, this is 3 by 2 minus 4 by 3 upon 40, and 4 by 3 V2 will be equal to, this is 1 by 240 plus 1 by 240. So this will be equal to 1 by 120. So V2 will be equal to 160. Now this is V2. So V2 is the distance of the fine image of this refraction. Now it is at 160. So the third refraction would occur at this surface. So the distance of the image which is situated at a distance of 160 from the curved surface will be 120 from this surface. And as we know that rays are moving from denser medium to rarer medium, and this is a refraction on plane surface, so we can say that for third refraction we will use the formula y is equal to x upon mu relative, and mu relative will be equal to 4 by 3. So y will be equal to x, which is the distance of the image from this surface, which will be 120. So it would be 120 into 3 by 4. So it is equal to 90. But 90 is its distance from this surface. So from lens it would be 90 plus 40. So the final image from the lens is 130, and it is real image because rays are actually moving in this direction and image is being formed at this direction. So this will be the real image. So the correct answer will be D. Now let us move on the next question. In this question, you can see that in a paramagnetic gas at room temperature, that gas is placed in a magnetic field of 1.5 Tesla, and the atoms have the dipole moment of 1 mu b, where mu b is the that mu b is Bohr magnetron, obviously. Okay, now we have to find out the energy difference between the parallel alignment and anti-parallel alignment of atoms' magnetic dipole moment with respect to the external field. So we know that first of all the energy of a dipole aligned in magnetic field is minus m dot b. So it is u1 for parallel alignment, angle between m and b will be 0 degrees, so it would be mb cos 0. And u2 for anti-parallel alignment, the angle will be 180 degrees, so it would be plus mb minus mb cos 180. So it is minus mb and this is plus mb. Okay, and obviously we can say that delta u will be 2 mb and m will be equal to EH by 4 pi m magnetic moment, and b is 3 by 2 Tesla. So delta u will be equal to 2 into 3 by 2 Tesla into b is m is EH by 4 pi m, where m is the mass of electron. This value will be approximately equal to 1.74 into 10 raised to power minus 4 eV. So the answer will be option B. Now this will not be the exact value. You will be getting a value which is nearer to this value. So we can say that this will be the correct answer. Now we move on the next question. In this question, you can see that there is a glass capillary tube whose inner diameter is 0.4 mm. This tube is vertically submerged in water so that the length of the tube protruding above the water surface, which means coming out of the water surface, is 25 mm. The surface tension of the water is 0.073 Newton per meter, and since this is given that water wets the glass completely, it means that the angle of contact is 0. So we have to find out the correct option. So we can say that first of all, it is given that the radius or the diameter of the tube is zero point 0.4. So the radius of the tube will be 0.2 mm, and this is vertically submerged into the water. Now we know that H is equal to 2t cos theta by r rho g, and here this small r, this capital R, is the radius of tube, and cos theta is 1 because theta is 0 degree. So H is 2t. Now t is 0.073 divided by R is uh, 0.4, 0.2 mm, and we have to convert it into the standard unit. So it would be 2 into 10 raised to power minus 4. Rho is obviously 10 raised to power 3 kilogram per meter cube, and G is 9.8. So H will be if we can approximately take this G as 10. So you can see that this H will be 0.073. This is the height. Okay, now obviously you can see that height is 0.073 meter, and in mm it is 73 mm, but the height of the tube above the water surface is only 25, and in this scenario in which tube is not sufficient for rise of water, so in this scenario we know that the water does not comes out of the tube. In fact, the meniscus adjusts itself so that water does not spills out, and we know that H1 R1 is equal to H2 R2, where H is the height of liquid column above the water surface and R is the radius of meniscus at the top. So H1 is 73 mm when the radius of the tube, when the radius of meniscus was equal to the radius of the tube, which is 0.2, and H2 is the final height which is given, so it is 25 because water cannot move beyond that 25 centimeter, which is the available length of the tube outside the water surface, and R is the radius of meniscus at that height. So R2 will be equal to 73 into 0.2 by 25. So I'll tell you approximately this is 73 into 0.2 divided by 25 is 5.584. So approximately we can say that it is 0.6. So 0.6 mm will be the correct answer. So water will rise up to the brim, forming a meniscus of radius 0.6 mm at the top. Now we move on the next question. In this question, there is a container A which has an ideal gas at a pressure of 5 into 10 raised to power 5 pascals at 27 degrees Celsius. And it is connected with the beaker B with a tube that is having a valve, and beaker B has a volume 4 times of that of A, and it has a gas at pressure of 1 into 10 raised to power 5 pascals at 127 degrees Celsius. Now this valve is opened and the pressure is allowed to equalize. So temperature of each of the container is maintained as the initial temperature. So we have to find out the common pressure in the two containers. First of all, let us see that the number of moles in the first container will be P1, which is P1 V1 upon R T1, and the number of moles in the second container will be initially P2 V2 upon R T2. These are the number of moles initially, and as the gases will mix, but they will not react obviously, but they will mix, and the number of moles will still remain the same, and the pressure will become common. So N1 plus N2, which is the total number of moles, will be now P is common, P by R is common, but volume and temperature of each of the container is different. So it is V1 by T1 plus V2 by T2. So we can equate these two. So it is P1 V1 upon T1 plus P2 V2 upon T2, and 1 by R is common. So cancelling 1 by R, P into V1 was, let's suppose V, and T1 was 300, plus V2 is 4V, and T2 is 400, and that is equal to P1, which is initially P1 was 5 into 10 raised to power 5, V1 was V, and temperature is 300, plus P2 is 10 raised to power 5, V2 is 4V, and the temperature is 400. So by substituting, by cancelling these values, P will be equal to 200 kilopascals. So this will be the correct answer. Now let us move on the next question. In this question, you can see that there is a thin plastic disc which is a quarter circle, and its radius is 0.6. It lies in the first quadrant of XY plane, and its center is the origin as shown. So initially the front surface of this quarter disk is charged with the charge density of sigma, and we have to find out the electric potential at this point. So we know that the potential due to disk is, let us write down here. So V of disk is sigma by 2 epsilon naught under root of r square plus x square minus x. This is the potential of disk. Now obviously the formula of potential will remain same for the quarter disk also, but due to the fact that this is a quarter disk, and we are given the formula for complete disk, so we can write that for quarter disk, this formula will be sigma by 8 epsilon naught. We are dividing it by 4. Now why I have divided it by 4? It is due to the fact that obviously if I write down the sigma, then if I write down the sigma in terms of charge, then charge will be Q and area will be A. But obviously if I write down this sigma for this quarter disk, so I can say that the potential due to 4 quarters will be getting summed up for the calculation of total potential at this point. So I can say that if potential of this quarter is V at this point, so the potential of the other 3 quarters will be V, and the total potential will be 4V, which will be this, and therefore the potential of 1 quarter will be this. Okay, so this is the formula, and obviously R is 0.6, and X is 0.8. So V of quarter disk will be equal to sigma by 8 epsilon naught and under root of R square, which is this, and X square, which is this. So it is 1, I can write it down as 1, minus X is 0.8. So V will be equal to sigma by 8 epsilon naught into 0.2. So V will be equal to sigma by 40 epsilon naught. So this will be the fourth, D will be the correct answer. Now let us move on the next question. In this question, you can see that there is a charge on a small point object which is kept at A, and this charge is producing an electric potential V is equal to 3 volt at this point P. Now, because of some unavoidable situation, this charge is getting leaked from this object at t is equal to 0 at a constant rate of 3 microcoulomb per second. And to maintain the potential of 3 volt at this point, we are moving this charge towards this point with certain velocity v. Now, when this charge crosses this point D, it is found to have a charge of 10 microcoulomb at this instant, and the velocity is like that, perpendicular to OD. Now, we have to find out the resultant magnetic field due to this charge when it is situated at D at point O. Okay, the distance OD is given as 1 meter. So first of all, we can see that if this charge is Q at any time and this distance is X, then the potential will be V is equal to KQ by X, and V is 3. So KQ by X is 3. So Q is equal to 3X by K. So dQ by dt will be equal to 3 dx by dt upon K. And dq by dt is minus 3 microcoulomb. So minus 3 into 10 raised to power minus 6. And this is 3 by K. And dx by dt is v, velocity. So velocity v, and there will be a negative sign because obviously x is decreasing. So cancelling this minus. So v will be equal to K, which is 9 into 10 raised to power 9 into 10 raised to power minus 6. It is 9 into 10 raised to power 3. This is the velocity. And we know that magnetic field at this perpendicular point, when the charge is situated at this point, will be mu naught by 4 pi and q v by r square. So B will be mu naught by 4 pi is 10 raised to power minus 7. Q is 10 into 10 raised to power minus 6. V is 9 into 10 raised to power 3. And R is obviously 1. So B will be equal to, this is 9 nano Tesla. So the correct answer is D. Now let us move on the next question. In this question, you can see that there is a electrical circuit that contains L, R and E. Now this switch is closed at t is equal to 0, and the current in the circuit is growing exponentially with time as depicted by this curve 1. Now the values of parameters E, L and R can somehow be changed, and the circuit is closed again for the second time after discharging this inductor, and the second graph is like that. So we have to choose the possible options which can be correct for this situation. So we can see that the peak value of these two curves is same, and we know that peak value I naught is E by R. So it could happen if E and R are unchanged or E by R is increased. In fact, E by R is unchanged and both E and R are unchanged. And you can see that the rate of charging of 1 is greater than the rate of charging of 2. So rate of charging of 1 is greater than the rate of charging of 2. You can see by this graph, rate of charging of 1 is greater than that of 2. And therefore we can say that the time constant of 1 will be less than the time constant of 2. Which means that L by R for 1 will be less than L by R for 2. Okay, so we can say that L by R has increased. Now we know that if E and R are kept constant and we have increased only the L, so this situation can occur. So A option is also correct. B says that E by R is unchanged but L by R has increased. This can be correct, obviously. And C says that E by R is unchanged but L by R is decreased. This is wrong because L by R has been increased. And the stored magnetic energy in the inductor has increased. So obviously if the situation is according to the first option, which says that E and R are constant but L has been increased, so we know that the energy stored in the inductor is half Li square. Okay, so the I naught is same still, but L is increased, so we can say that the magnetic energy uh, has increased. Now let us also check this for the B option also. So for this B option, if we say that E by R is unchanged but L by R has increased. So you can see that if E by R is unchanged, that then I naught is same but L by R has been increased. So this can be done by decreasing R and decreasing E by the same factor. Let us suppose that we have decreased R by 2 times. So new R is R by 2 and new is E by 2. So the E by R will remain same. But if new R is R by 2, then L by R will be increased, but L is not being changed. So if E by R, which is I naught, is same, L is same, then magnetic energy may or may not be increased. So we could not say that D would be the correct answer. So we have to, because it is saying that has increased, which means that definitely magnetic energy has been increased. So we could not comment on this. Okay. So now let's move on the next question. In this question, you can see that the earth is revolving around the sun. Sun has a mass of m in a circular orbit of radius r, and the time period of revolution is 1 year. Now suppose that during this revolution of earth around the sun at any instant, the mass of the sun is instantaneously doubled, which is initially it was m, and at any instant it is doubled to 2m. Now we have to choose the correct alternatives. So obviously the total energy, just now we know that just before doubling the mass, the orbital velocity of earth will be under root of gm by r. Okay, and the kinetic energy of the earth will be half m v naught square will be gmm by r. Now just after doubling the mass, the total energy will be the sum of potential plus kinetic. So if suddenly mass is doubled, then kinetic energy would not be changed at that instant suddenly, and the potential will change because mass is doubled. So now new potential will be minus 2gmm by r, and the kinetic energy is this plus gmm by small r. So this is the new, in fact there is 2 also here, so this is 2. So this is the new total energy after doubling that mass. So this total energy is minus 3 by 2 gmm by r. Now we know that suddenly if at that instant the potential energy is doubled, in fact magnitude of potential energy is doubled, then this particle will leave the circular path and will transit into the elliptical path. And we know that in elliptical path the total energy is gmm with a negative sign upon 2a, where a is the semi major axis, and mass of the sun is also twice, so there will be a 2 here also. So cancelling this 2 with 2, a semi major axis is 2r by 3. Now initially at the instant when the mass was not doubled, it was moving in a circular orbit like that. I'll draw the diagram. This is sun and this is earth and this is r, and semi-major axis is 2r by 3, which means that this is r max. So we know that r max is a into 1 plus e, where e is eccentricity, so r is equal to 2r by 3 into 1 plus e, and cancelling r with r, so e will be equal to half. You can see that e is half. Now r minimum will be a into 1 minus e. So a is again 2r by 3 and 1 minus e is half. So this is r by 3. So minimum distance of that of earth near the sun will be r by 3. So C option is correct. We'll talk about the time period later on, and there is no change in angular momentum. Obviously this is correct, because at any time the force of gravity acting on earth will be acting towards the sun, or I'll say that pointing towards the sun. Therefore the torque of this force about sun is 0. So angular momentum of earth about sun will not change. And let us now first of all find out the maximum speed. Now as we know that angular momentum is conserved, so we can say that v1 by r1, v max into r minimum will be equal to v minimum into r max. Now v max, we have to find out the v max, and r minimum is r by 3. Now v minimum was v naught, which was this under root gm by r, and r max was equal to r. So you can see that v max is 3 under root gm by r. So this is also the correct option. And the time period of revolution of earth around the sun will be, now initial time period t is 2 pi under root r cube by gm. Now we know that finally t dash time period will be 2 pi under root of a cube, where a is the semi-major axis and m is the mass of sun, so it would be 2m. Okay, so this will be the new time period. We know this formula already. We have derived in gravitational playlist. So this is semi-major axis. So t dash will be 2 pi. Now semi-major axis was 2r by 3. So this is 2 r by 3 is 2 to the power 3 is 8 r cube by 3 to the power 3 is 81, and this is 2 and this is gm. So this t dash will be equal to 4 by 9 times of t. So t was 1 year, so A option is incorrect. So the correct answers are B, C and D. Now let us move on the next question. In this question, you can see that there is an optical fiber and it consists of glass core of refractive index N1, and it is surrounded by a cladding of refractive index N2. Obviously, the refractive index of core is greater than the refractive index of cladding, and this light ray enters in this optical fiber at an angle of theta from air, and it travels through the optical fiber like that. So the maximum value of theta for which ray can travel down this optical fiber is sine inverse n1 under root n1 square minus n2 square. We have already discussed about the numerical aperture of optical fiber, which is sine of this theta max. Now this is under root of n of core square minus n of cladding square and divided by n of surroundings. So this is the formula of numerical aperture, and obviously surrounding medium is air, so n surrounding will be 1. So this will be under root of n1 square minus n2 square. So theta max will be sine inverse under root of n1 square minus n2 square. Now option B is obviously wrong, and option C says that if theta is 30 and n1 is 3 by 2, then for reflection at critical angle the value of n2 should be root 2. So if theta is 30, let us see this situation, that if theta is 30, then let us write this angle as alpha. So 1 sine 30 will be equal to n1, which is 3 by 2 sine alpha, and sine alpha will be equal to 1 by 3. Now cos alpha will be equal to 2 root 2 by 3. So this angle I will be equal to 90 minus alpha. So for TIR at this point, this should be the critical angle. This should be the theta C, and we can write down n1 sine theta C should be equal to n2 sine 90, because at an angle of theta C, critical angle, the emergence angle should be 90. So n1 is 3 by 2, sine theta C is sine 90 minus alpha, which is cos alpha, and n2 is, we have to find out the value of n2, and sine 90 is 1. So this is 3 by 2 into cos alpha, which is 2 root 2 by 3. So the value of n2 should be equal to root 2. So the correct answer will be C also. Now if a ray that enters this optical fiber from point P at an angle of 0 degree travels from P to Q, which is at a distance of L inside the fiber directly, and the other ray which travels like that after repeated TIR takes some time, which is different time, because the ray which is traveling in the straight direction will take less time, and the ray which is traveling like that will take some more time. So the difference of those time is this. So we have to check this option. So this is correct. This is the correct one. Let us use another page, or let us do it here only. So you can see that if this is L, so the time t1 which is taken by the ray which is traveling in the straight direction will be L by V, and we know that n1 will be equal to C by V. So V is equal to C by n1. So T1 will be equal to L n1 by C. This is the time taken by this ray. And now let us suppose that this is S. This distance is S. So we know that S cos alpha into 4, or I can say that this would be L by 4. L by 4. So S cos alpha is L by 4. So S will be equal to L by 4 cos alpha. And the total distance is S, S, S and S, 4S. So the time T2 will be 4S upon V. So 4S is L by cos alpha, and V is again this one, V is C by n1. So this is C by n1. Okay, and the value of cos alpha. Obviously, this is cos alpha is sine theta C, because alpha plus theta C is equal to 90. So cos alpha is sine theta C. So we can say that T2 will be equal to L n1 upon sine theta C into C. L n1 upon sine theta C into C. And sine theta C is equal to n1 upon n2, or n2 upon n1. Okay, and T2 will be therefore equal to L n1 square by n2c, and the difference of time delta t will be equal to L n1 by c, L n1 by C minus L n1 square by n2C. So taking out L n1 by C common, it would be 1 minus n1 by n2. So it is L n1 by n2 into n2 minus n1. So this is the correct option. So the correct answers are A, C and D. Okay. Now we move on the next question. In this question, you can see that there is a series LCR circuit that is given a resonance angular frequency of 2 into 10 raised to power 4 radians per second. Now the same circuit is being driven with the angular frequency of 5 by 2 into 10 raised to power 4 radians per second. And it is observed that at this frequency the impedance of the circuit is 1 kilo ohm and the phase difference between current and voltage is 45 degree. So the values of L, C and R can be. So first of all, we know that omega resonance is equal to 1 upon root LC, and omega resonance will be 1 upon under root of L, which is equal to this 78.6 into 10 raised to power minus 3, and C is 31.8 into 10 raised to power minus 9. So this omega resonance will be exactly equal to 2 into 10 raised to power 4 radians per second. So we can say that B and C can be the answers. And at this frequency, XL will be omega L. This is 5 by 2 into 10 raised to power 4, and L is 78.6. So this will be 1965 ohms, and XC will be 1 upon omega C. So it would be 1 upon omega is 5 by 2 or 2.5 into 10 raised to power 4, and C is 31.8 into 10 raised to power minus 9. So this XC will be 1258, and we know that tan phi is XC, in fact XL minus XC by R, and obviously XL minus XC is 707 upon R, and phi is 45 degrees, so this is 1, so R will be equal to 707 ohms. So the correct answers are A, B and C. Now we move on the next question. In this question, you can see that there is a long straight wire having a radius, that is radius of cross section, that is greater than 4 mm. It carries a current that is uniformly distributed over the cross section, and the magnitude of magnetic field due to this current is 0.28 millitesla at 4 mm distance from the center, and is 0.20 millitesla at R is equal to 10 mm from the center. We have to choose the correct options. First of all, let us write down the formula of magnetic field inside the wire. So it is mu naught J R by 2. This is B in, and B out will be mu naught J. You can find by Tesla, that is Ampere law. So B dot dl will be equal to mu naught I, because at a point which is outside this wire will be mu naught I, which is the complete current flowing inside the wire, and limit of Amperian loop will be 0 to 2 pi r small r. So B into 2 pi small r will be mu naught I by mu naught I, and B will be equal to mu naught I can be written as J into pi capital R square, because current is flowing in the cross section of wire only, so divided by 2 pi small r. So B out will be equal to mu naught J R square by 2R. These are the important formulae. Now B out will be this one. I have already written this formula, and now let us write down the formula and erase this one. So this is mu naught J R square by 2R. So now let us talk about the options. So the first option, first of all, let us find out the current density. We can see that the magnetic field inside the wire is directly proportional to the distance from the center. So as we go away from the center, the magnetic field should increase. But you can see that at 4 mm distance from the center, magnetic field is this, and at 10 mm it is decreasing. It has decreased to 0.2, which means that this point is lying outside the wire. So we can say that mu naught J R by 2 will be equal to 0.28, where R where the value of R will be 4 into 10 raised to power minus 3, and divided by 2 it is 28 into 10 raised to power minus 5 Tesla. So from this, J will be 1.1 into 10 raised to power 5 ampere per meter square. So D option is correct. Now the magnetic field at the point this is this one. So B out is mu naught J R square by, in fact, first of all, let us write mu naught I by 2 pi R. Okay, B out. This is also the formula for magnetic field outside the wire. It is 0.2 into 10 raised to power minus 3 Tesla, and the value of R is small r is 10 raised to power minus 2 meter. So the value of I will be 10 ampere from this. So C option is incorrect. Now I is equal to J into pi R square. So R will be approximately 5.4 mm of this wire, and therefore option, if we talk about the option A, then magnetic field at R is equal to 2 mm. This is also the point which is lying inside the wire because radius is this. So we can say that B in 1 upon B in 2 will be R in 1, or we can say R1 by R2. So B in 1 is 0.28, so it is 0.28 divided by B in 2, and R1 is equal to 4 and R2 is 2. So you can see that B in 2 is 0.14 millitesla, so A option is also correct. B in 2 is 0.14 millitesla by this ratio. Okay, and for option B, the magnetic field at 5 mm is greater than the magnetic field at 6 mm distance. So let us use the new page. Now 5 mm is the point which is inside the wire and 6 mm is the point which is outside the wire. So B at 5 upon B at 6 mm distance is should be in the ratio of R which is 5 mm. So we know that inner point has the magnetic field directly proportional to small r. So that is 5. J will be cancelled out, and B at 6 will be capital R square upon R. So it would be capital R square is 5.4 whole square into R is 6. So B at 5 upon B at 6 will be equal to 30 upon 5.4 whole square, which is slightly greater than 1. So B at 5 is greater than B at 6. So we can say that B is also correct option. So the correct options are A, B and D. Now we move on the next question. In this question, you can see that there is a combination of capacitances is given, and this combination is connected to 12 volt battery. So we have to find out the equivalent resistance of the system, energy stored in the system, potential difference between X and Y, and potential difference across C2. So for this, I'll recommend the nodal analysis. That would be the best method to apply in these kind of problems. First of all, let us draw the circuit and let us see that if it is a Wheatstone bridge or not. So this is 4 microfarad, C3 is 2 microfarad, and C2 is 2 microfarad, and C4 is 4 microfarad, and C5 is 3 microfarad. This is 3 microfarad. So you can see that this is, although this is a Wheatstone bridge, but it is not balanced, so we cannot apply that analogy directly. So we have to ground this circuit first of all to apply the nodal, and if we ground this terminal, then the potential of this terminal will be 12. Let us suppose that the potential of this node is V1 and potential of this node is V2. Now we will apply the nodal on these two nodes. So we know that when we apply the nodal, we are actually adding the charges flown in all three directions, assuming that V1 is highest if we are applying at this node. So V1 minus 12 into 4 plus, because Q is equal to C into V. Okay, so this is V1 minus V2 into 3 plus V1 minus 0 into 2 is equal to 0. So 4V1 minus 48 plus 3V1 minus 3V2 plus 2V1 is equal to 0. So you can see that this is 9V1 plus, in fact 9V1 minus 3V2 is equal to 48, first equation. Now let us apply the nodal on the second node. So that would be V2 minus 12 into 2 plus V2 minus 0 into 4 plus V2 minus V1 into 3 is 0. So this is 2V2 minus 24 plus 4V2 plus 3V2 minus 3V1 is equal to 0. So you can see that it is 9V2 and minus 3V1 is equal to 24, and 3V2 minus V1 is equal to 8. This is second equation. Now let us add these two equations. So you can see that 8V1 will be equal to 56 and V1 is equal to 7 and V2 is equal to 5. So Vx minus Vy will be equal to minus 2. In fact, V2 is the potential at this node. So Vx is 7 and Vy is 5. So Vx minus Vy is 2. So C is correct. And let us talk about the equivalent capacitance of this system. So first of all, let us redraw the circuit. This is the main circuit, and this is 4, this is 2, this is 2, this is 4, this is 3. Okay, yes. Now let us find out the charge Q1 and Q2. So Q1, you can see that the potential difference between these two terminals is 12 minus V1, which is 12 minus 7, it is 5, and Q is equal to CV. So potential difference across this 4 ohm is 5. So Q1 is equal to 4 into 5, which is equal to Q is equal to 4 into 5. So it is 20 microcoulomb. And Q2 is the potential difference 12 minus V2 will be 7. 7 into 2 is 14. So it is 7 into 2 is 14 microcoulomb. So the total charge that is flowing is Q is 34 microcoulomb. Okay, and we know that the battery which we have applied is this. So Q total will be equal to C equivalent into V. So Q total is 34, C equivalent is unknown, and V is 12. Okay, so C equivalent will be equal to 34 by 12, which is 17 by 6. Okay, so this would be the equivalent capacitance between A and B, but this is not the correct answer. So This is not the case. Now the energy stored in the electrical system is 204 microjoules. So energy is half C equivalent is 17 by 6 and V square is 144. So this would be equal to 24 and this is 8 and once this is 17 into 8, so it would be equal to 136. So you will be 136 microjoules. Okay, and the potential difference across capacitor C2 is 8 volts. So let us verify the potential difference across C2. That is also not the case. So the correct answer is only C. Now we move on the next question. So energy is half C equivalent into V square. So it would be half C equivalent is 17 by 6 and V square is 144. So this will be 17 into 12. So it would be equal to 204 microjoules. So the correct option will be B and C. Okay, so now let's move on the next problem. In this question, you can see that 1 mole of an monoatomic ideal gas, which is initially at a temperature of T, is compressed to 1 by 8th of its initial volume by a piston fitted in a cylinder, such that the heat dissipated into the environment is equal to the change in the internal energy of the gas. So obviously we can say that the heat dissipated dq is equal to the change in internal energy of the gas, and this is very important to note that it is given that heat is being dissipated, which means that heat is lost by the system. Therefore we can say that dq is minus and the magnitude of dq is du. Okay, so we can say that it is du, minus of du. So we can easily say that dq is nc dt and du is n cv dt. So we can say that c is equal to minus cv and cv is f by 2r, and f for monatomic gas is 3, so this is 3 by 2r. So first option is incorrect. And now if we talk about the process, so we know that C is Cv plus R upon 1 minus N, where N is the coefficient of polytropic process. Okay, and C is this is minus, or we can say that C is equal to minus Cv. So minus 2Cv is equal to R upon 1 minus N. And Cv is R, obviously minus of 2 into Cv is F by 2 into R, and F is 3, so this is 3 by 2R, and that is R, and that is 1 minus N. So you can see that 1 minus N is equal to 1 by 3 and with a negative sign. So n minus 1 is 1 by 3, so n is equal to 4 by 3. So the process equation is PV to the power 4 by 3 is equal to constant. And now let us talk about the final temperature. We know that if the process equation is PV to the power 4 by 3 is equal to constant, we can substitute the value of P as nRT by V. So it would be T into V to the power 1 by 3 is equal to constant. So we can say that the initial temperature and initial volume is T and V, and the final temperature is T dash and final volume is V by 8. So you can see that T dash will be equal to twice of T. So the final temperature will be twice of T. Now work done. So work done in any polytropic process is equal to nR delta T divided by gamma minus 1. Okay, and obviously we can say that this is work done on the gas, which means that the work done by the gas is negative, obviously, because gas is being compressed, and work done will be equal to initial n is obviously n, r is r, and I think n is 1. Obvious, it is given in the question that n is 1, r is r, and delta T is T minus, or we can find out the magnitude only, and gamma for this gas. Now this is gamma for adiabatic process, but for this process it would be n, so that is n minus 1. Now n in this process is 4 by 3, so work done will be RT divided by 4 by 3 minus 1, which is 1 by 3. So work done will be equal to 3RT. So the correct answers are B, C and D. Now let's move on the next question. In this question, you can see that there is a solid ball of mass m and radius r. It is lying on a horizontal table on which it is not mentioned that whether there is friction present or not. So we cannot assume the friction on our own. So this ball is being applied with a short impulsive force at this point and at a height of alpha r from this central line. This impulse provides a momentum p to the ball, and we have to find out the correct option. So we can say that if the momentum of the ball is p, then its kinetic energy will be obviously p square by 2m. So this is obviously the translational kinetic energy, so option A is correct. Now the energy of pure rotational motion of the ball is this. Now let us first of all see that we cannot assume the friction on our own, and the angular impulse acting on the ball about this center will be this linear impulse, which is p into this distance alpha r. This is the angular impulse. So p alpha r will be equal to I omega, which is the change in angular momentum, and I is the moment of inertia about COM, because we have written this angular impulse about COM. So it is equal to 2 by 5 mr square into omega. So omega will be equal to 5 by 2 alpha into alpha divided by mr into p. This is the value of omega, and the energy is this is rotational kinetic energy. So rotational kinetic energy will be half I omega square, and this is half I is 2 by 5 mr square into omega square. Omega square by 25, omega square will be 25 by 4 alpha square p square divided by m square r square. So cancelling this r square with r square, m with m, this 2 with 2, this with this is 5. So kinetic energy of rotational motion will be 5 alpha square p square by 4m. So this B option is correct, and we know that this height h is k square by r if this ball performs pure rotational motion without or with the presence of friction. So this height should be k square by r, and k for this solid sphere is under root 2 by 5 r. So k square by r will be 2 by 5 r. So alpha will be equal to 2 by 5. So C option is also correct. And alpha, if alpha is 0, then pure rotational motion will be observed. So you can see that if alpha is 0, then you are applying this impulse on this line. So if impulse is applied on this line, then there will be no angular impulse produced about the center, or no torque is produced about the center. Therefore, it will not rotate, and it will only translate, because we cannot assume friction. So pure rotational motion will not be observed if alpha is 0. So D option is incorrect. So the only correct answers are A, B and C. Now let's move on the next question. In this question, you can see that according to Bohr's theory, in the ground state of hydrogen atom, the electron revolves in the circular orbit of radius r, and the velocity of that electron is v. The frequency of revolution, circulation frequency, is f, and the magnetic dipole moment of the orbit is pm, which is, we know that it is Bohr magnetron, mu b. So that mu b is given as pm. So the magnetic field, we have to find out the magnetic field circulating. In fact, the magnetic field of that circulating electron about the center, at the center, is B. And then for helium plus ion and for a second orbit, we have to check the correct options. So we know, first of all, that radius of orbit is r0 into n square by z. Okay, where r0 has a specific value, that is 0.529 angstroms. So for the helium, obviously for helium, z is 2 and n is 2. So you can see that for helium it would be this is r into n square will be 4 and z is 2, so it would be 2r. So A option is correct. The magnetic dipole moment. Now magnetic dipole moment, Bohr magnetron, mu b, is n times of mu b. This is the magnetic dipole moment of electron in any orbit. It does not depends on z. So obviously if n is 2, then it would be 2 times of pm. Now frequency of circulation. So frequency f is equal to omega by 2 pi, and omega is v by r. Okay, so this would be the frequency, and v, we know that velocity is v naught into z by n. So velocity v dash will be v into z is 2 and n is 2, so v will be same. And as this radius is doubled, therefore frequency f dash will be f by 2, because v is same and radius is doubled. So C is the correct option. And the magnetic field at the center, B, is mu naught I by 2r. Now we know that I is equal to q omega by 2 pi. So if omega has become halved and radius has become double, so B dash will be equal to B by 4. So D will be correct also. So the correct answers are A, B, C, D. Now let us move on the next question. In this question, you can see that there is a body of mass 0.25 kg that is moving along the x-axis under the action of conservative force. This body has a potential energy as a function of x that is given by minus 100x upon x square plus 4 joules. Then we have to select the correct option. So first of all, the potential energy is minus 100x upon x square plus 4, and F will be equal to minus du by dx. Okay, so F will be equal to plus of 100 and d by dx of x upon x square plus 4. Okay, now F will be 100 and the differentiation of this term will be x square plus 4 whole square, and x square plus 4 into differentiation of x is 1 minus x, and differentiation of x square is 2x. So f will be equal to 100 into, this is 4 minus x square and divided by x square plus 4 whole square. This is force F. Now you can see that this is the force, and this force is 0 at x is equal to plus minus 2. So these are the two equilibrium positions, and obviously if you substitute this plus 2 here, then you will be minimum, and if this negative 2 is substituted here, then you will be maximum. So which means that at x is equal to plus 2, u is minimum, and that is equal to minus 100 into 2 divided by 8. So it is minus 25, and u max will be when x will be equal to minus 2, so it will be plus 25. So minus 2, first of all, at x is equal to 0, you can substitute x is equal to 0. The force will be 400 upon 4, 4 square. So 400 upon 16 will be 25. So A option is correct. Now at x is equal to plus 2, you can see that potential energy is minimum, so it will be the stable equilibrium position. And at x is equal to minus 2, potential energy is maximum, you can see. Then it would be the unstable equilibrium position, and this body executes SHM with the angular frequency of this. So let us check this scenario. So let us use a new page. We can see that the stable equilibrium position is x is equal to plus 2. So this body will execute SHM about stable equilibrium position only. So let us suppose that this body is at a distance of x from the origin. So in the equation of SHM, we know that x is the displacement from the mean position, and mean position is this one. So let us suppose that this displacement is capital X. So small x is 2 plus capital X. So we can put this small x in this equation. So this is 100 into 4 minus x square. F is 100 into 4 minus x square upon x square plus 4 whole square. So F will be 100 into 4 minus, this is 2 plus x whole square divided by 2 plus x whole square plus 4. So F will be equal to, you can see that it is 100 into 4 minus or we can we can do it like that only. So minus 4 minus x square and minus 4x divided by it would be 2 plus x whole square plus 4. Okay, so you can see that F will be equal to, this 4 is cancelled, so F will be equal to 400. In fact, you can take minus common, so it would be minus 100 into x, and this is x plus 4 divided by this is 2 plus x whole square plus 4. Okay, now what we can do, we can just put the value of x. X is, so x is tending to 0, so we can say that F will be equal to minus 100 into x plus 4 divided by, this is 8 plus x square, and this is plus 4x whole square. So you can see that we can neglect this value of y. So f is minus 100. We can neglect this y square, higher terms, into 4y divided by, we can neglect this y also. So this is 2 square, that is 4. 4 plus 4 is 8. 8 square is 64. So f is equal to 25 by 4 y with a negative sign, and that is minus m omega square y. So m is 1 by 4 because it is given as 0.25. So omega square will be 25 and omega will be 5. So option D is incorrect. Now we move on the next question. In this question, you can see that there is a uniform rod OA of length L, which is pivoted at this end O. C is the midpoint of this rod, and this rod we have to choose the correct options. So first of all, we have to find out the time period of small angular oscillations of this rod. So we know that it is a compound pendulum, and in the compound pendulum the time period is 2 pi under root I about hinge by mgd, where d is the distance between COM and hinge. So t will be equal to 2 pi under root I about hinge is m L square by 3, and this is mgd, d is L by 2. So cancelling m with m, L with L, so t will be equal to 2 pi under root 2L by 3g. So this is incorrect option. Now the rod is brought to horizontal position and then it is released from rest. Then the angular velocity of the rod at the instant when it is vertical. So if this rod is released from this position like that, and we have to find out the angular velocity of the rod when it is vertical. Okay, so we know that the center of mass of the rod has descended by a distance of L by 2, and the work done by gravity is mgL by 2, and that is equal to half I omega square, where I is ml square by 3 into omega square. Cancelling m with m, 2 with 2, L with L, omega is equal to 3g by L under root. So B option is correct. And D option says that after braking, the lower part falls vertically and rotating about its center. So it is saying that after rod, this part, lower part has braked off. This lower part falls vertically downward, which means that the COM of this lower part goes in the y direction only. This is wrong because obviously at just before the breaking off, the velocity of the COM of the lower part will be in this direction, and just after the breaking off it would go in a parabolic manner like that, rotating about the center. The COM will go in parabolic path. So this is wrong. So obviously D option is incorrect. Now see, now when the rod, oscillating rod comes to the vertical position, it breaks at the midpoint without generating any impulsive force, and the largest angle from the vertical reached by the upper part OC is 60 degree. So we can see in this scenario that when this upper part of the rod is just before the breaking off, this upper part was rotating with an angular velocity of omega, and just after breaking off, its angular momentum of the upper part only will be conserved, and therefore it will be still rotating with the angular velocity omega. Now omega we have already calculated as 3g under root of 3g by L, and by conserving the energy, half I omega square is equal to mgh, we can find out the angle. So I will be, now mass is m by 2 and L is L by 2 whole square divided by 3, because the formula of moment of inertia is ml square by 3 and this is omega square, it is equal to mgh. So this is 4 and 416 into 348. So ml square omega square by 48 will be equal to mgh. And we can substitute the value of omega. So this is L square, omega square is 3g by L, so it would be L divided by 48 and it would be equal to gh. So this is Lg by 16 is equal to gh. So h is equal to L by 16. Okay, so you can see that this is the h. What is h? So if we, this is L by 4 and when this rod will be like that, so the height ascended h will be L by 4 into 1 minus cos theta. Okay, so you can see that this will be equal to, h will be equal to L by 4 into 1 minus cos theta. So cancelling this L with L, cos theta is now you can we have done a little mistake that it would be m by 2 because mass is also half, so there will be a 2, so it would be 24 and this will be 8. Okay, so this is 8, so this is 8, so cos theta is half, so theta is 60 degree. So this will be the C option will be the correct answer also. So the correct options are B and C. Now let us move on the next question. In this question you can see that a boy stands on a stationary ice boat that is placed on a frictionless horizontal flat iceberg. This boy and the boat have combined mass of 60 kg. So let us assume only that there is no boat and there is only boy. Let us delete the boat and let us assume only a boy that is standing on a skateboard. Okay, so this mass is 60 kg of the boy. This boy has two balls of mass 10 kg and 20 kg and it is holding that those balls. Now in order to get the boat moving, the boy throws the balls in the backward direction horizontally, either in succession or together. So in each case the balls are thrown in the backward direction with the speed v relative, that is 6 relative to the boat when it is being thrown. So we have to find out the resultant speed of the boy and the boat. So first of all, let us consider the case when they are thrown together. So let us see that when they are thrown together, that mass is 30 kg. Okay, and this is thrown in the forward direction with velocity v1, and this is thrown, this will be going in the backward direction with velocity v2. Okay, and initially they were at rest, so initial momentum of this system was 0 and final momentum of this system will be 30 v1 minus 60 v2 and that would be 0, so v1 will be equal to 2 v2. Okay, and the relative velocity v1 plus v2 will be 6, so you can substitute the value of v1 here. So 3 v2 is equal to 6, so v2 is equal to 2. So when they are thrown together, the speed of recoil of boy and the boat will be 2 meters per second. Now in this B option is obviously incorrect. So in the C option, that if the balls are thrown one after the other, first M1 and then M2, Then in this case, let us see the scenario that first of all, uh, boy throws a ball of mass m1 which is 10 kg in the forward direction, and the remaining mass of this system will be 60 plus 20, that is 80 kg, and the mass of ball thrown is 10 kg, so this is 10 kg. And let us suppose that it is again thrown with velocity v1 and it is recoiled with velocity v2. So initial momentum is 0, and obviously final momentum will also be 0. So 10 v1 minus 80 v2 is equal to 0. So v1 is equal to 8 v2, and v1 plus v2 is 6 again. So you can see that 9 v2 is equal to 6 and v2 is equal to 2 by 3. Now this v2 is the velocity of this system. Now at this stage, when it is going in the backward direction, so the momentum of this 80 kg system in the backward direction P is 80 into 2 by 3. So this is 160 by 3. This is the momentum of the system at this stage. Now this boy again throws a ball which is of 20 kg from this system in the forward direction with velocity, let's suppose v1, and now this v1 v2 we have already used, so I am again assuming v1 v2 separately. So the remaining mass is 60 kg. So again the initial momentum was in the backward direction, so 60 v2 minus 20 v1 is equal to initial momentum, that is 160 by 3, and the second equation will be the relative one. So the relative velocity now will be v1 plus v2, that is again 6. So we can substitute the value of v1 as 6 minus v2 in this equation. Okay, so 60 v2 minus 20 into 6 minus v2 is equal to 160 by 3. So 60 v2 minus 120, 60 v2 minus 120 plus 20 v2 plus 20 v2 will be equal to 160 by 3. 160 by 3. So 80 v2 will be equal to 120 plus 160 by 3. So this is 360 plus 160, that is 520 by 3. 520 by 3 is 80 v2. So v2 will be equal to 13 by 6. So 13 by 6 is approximately, I guess 13 divided by 6 is 2.1666. So this will be the correct answer. And if we repeat the same process for the D option, then you will find that D will also be the correct answer. So the correct answers of this question is A, C and D. Thank you. So this was the most accurate and errorless and the shortest solution video of NSEP 2024 made by a single person, that is me. Okay, so you can easily verify all the other videos and the solutions. This is the simplest and shortest solution video, and this is absolutely single-handedly made by me. So we'll be waiting for the official answer key to be announced, and I've also attached the answer key at the end of this video. You'll be watching that answer key. So this was all, and in coming days I'm separately making the playlist of INPHO and Olympiad sections also. So thank you.